now, of course, I do a lot. Oh yeah, so true. Spin-off. Yeah, cool. Thank you. hi. Yeah, cool. Yeah, you've been like, you're getting late. So like, around an hour. So, yeah, we'll get out now. Like, oh, yeah, gotcha. Thank you. Yeah, thank you for coming. By the way, it's really a long time no see. Yay. Yeah, with slaps. Oh, yeah, 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 that one. Yeah, 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 so true. Yeah, yeah, yeah. Oh, really? Oh my gosh. Yeah, so true. Hey, folks, you wanna first too? So please keep it, okay? Everyone, we're going to start 1 minute. So please be seated, okay? Thank you. Hey, folks, we are going to start reading a minute. We're going to start reading a minute, so please be seated, okay? Hey, folks. Hey, folks, we are going to start within a minute. Thank you. Hello, folks. Thanks for coming today. It's really good weather, right? Yeah, I really like the vibe today. Today is like our team is like hosting two events too. Like this is our first OmOCon in San Francisco, and we're like also like hosting the hackathon along with team attachment. It's like also like AI build clubs there. So like it's really nifty. And for myself, I never like kind of the convene of my event outside of the APAC region. So well, I just like participate a lot of times for like event or some meetups or the hackathons and stage or in Canada. I'm from South Korea, but I've lived in Vancouver right now, and it's really nifty one. So yeah, we're like trying to hold this the first ever OmOCon. So like thanks for like coming here today. Let's just see. So who else in the like on my open agent Discord server, Salesforce Discord server, Graph ever? Yeah, yeah. So they. What others like who? How did you get to know about this event in the first place? The Luma page or some Twitter? How did you get to know? Luma, okay. Yeah, so it's been featured in the Luma as well. So like we have around 150 RSVPs, and yes, it's a pretty much though. And I just like kindly ask if you don't have any time to scan this one and to like this is a pretty quick like fun survey. So if you have not done so far, please do like kindly ask to scan the form, and I will just try to like announce what it is. Okay. Just enjoy, okay? Okay, so yeah, that's a first check here. So let's just see. That's the same chart coding. So yeah. Ghost? Typeform is Ghost. So this one's Ghost, this one's Ghost. Okay, so previous one? I will just do this one, okay? So that's the same thing. Okay, so I have around some responses here. So I will just like pause. It's broken? Let me see. It's a bit weird because I have checked. I have some result here. So let's see. Is it? Let's see. It's a bit weird though. Wow, why is it not close? Well, I'm not a super like expert at Typhoon though. You cannot able to look at, right?
Did you create
Still.
the platform using OpenCode?
Oh no, like I just manually made by myself. Okay, so so like we just did a bit for like last an hour. So let's just try to see this one, okay? So the first so the very first okay, so the very first question was like how many hours do you spend talking to your like codecs and OpenCode or Cloud Code itself? And everyone says more than 4 hours, right? There's one guy who's 2 or 3. How can you learn 2 or 3? And honestly, I thought that there's an option for more than 12 hours or 16 hours, right? Because like whoever runs the in the terminal by myself, right? Do you agree, Hugh?
I don't actually know.
Yeah, so true. Like who else in open terminal, honestly? So like what I mean is like just like it's getting more kind of doing some more experiments for the class or some the bots to want to run the terminal with like calling the agent instead of me. So now I'm just like doing the same experiment on my own Discord server. So like it just like try trying to get kind of the issues instead of me. And we just try to run. I have never asked to run in the first place, so it's kind of a bit kind of new kind of the way of like using it like agent in these days, I believe so. So like by the way, so that's the second one is like, what is your guess of the average time spent per day on codecs and people at this event? So it's different one, right? So it's like your ones. It's like what others think. So like other things like 1 or 3 hours. Why is it 1 or 3 hours only? Yeah. Didn't work? Okay. This is my miss, okay? Okay, so what's the third one? So you will play Kiss and Marry, and you must choose like which you're gonna kill in the first place, right? So that was the third one. Everyone, well, someone says Haspies, someone says the Rat, someone says the Dre Automaray, right? Oh, well, you're gonna kill the Automaray? Okay, interesting. So what is the next one is like you will play like Marry, okay? We're gonna marry. Amude, Altman. It's a bit kind of the proportions we have, right? Dax and Rat. Okay. So what's the next one? So next one says, I do remember. Who? Okay. That was a man. No, that was a kiss. Okay. That was a kill. So who gonna kill in the first place? Altman, Sam Altman, Sam Altman, Sam Altman. Oh, you guys hate Sam Altman. So you guys love Anthropic and gonna kiss with Umbre, and you're gonna kill Sam Altman. Okay. Interesting. Yeah. Interesting part. Okay. So like this one is a very like tricky questions. Like, would you rather keep a one coworker or to just use like GPT 3.5 Turbo while keeping your coworker, right? And everyone says keep a one coworker. Interesting. Yeah. Okay. And so this one? So this question is like, would you rather make your chat history public, or would you rather make your private browsing history public? And everyone says, oh, it's a bit kind of, yeah, it's two says it's a make your ChatGPT cloud history more. Oh yeah, interesting. So there's only one guy says like, I want like reveal my private history, and everyone says I want like reveal my ChatGPT history. Interesting, right? So it's like getting kind of more like changes, like how you gonna like say more some sensitive things in your sessions in the first place, right? And this is the last one. So what is your timeline on Asia? It's a pretty much kind of balance, I would say, but it's more like 3 years, I believe. So the people just try to have some kind of the publish in the first place. Yeah, so it's kind of the quiz, and I just sorry that I'm really bad at creating typeform here. So but it's okay. We just have fun. But it's my mouse here. Okay, gotcha. So that was the first chat. And now for the sponsors, like we have some sponsors to want to make sure this event happens. And I have no idea how to book the venue in San Francisco because I have never booked in my life. And well, for this Saturday, I just need to want to book at least 2 venues. And I booked in one Wait and Bio's headquarters for a hackathon, and I booked here in the Frontier Tower for the conference. So like I also just try to like book the same the event the same building for the 2 events, so that makes so people just like come and work and like going back and forth. But yeah, just like for hackathon stuff, like there are more demands to want to like register after getting some of the open AI exposure. I don't know. So after that, we just like change the venue a bit, and then we just keep this venue in the 6th floor. And I really love the kind of the atmosphere of this here. So like it's kind of a bit one. So like I just want to like shout out to outside a bit more because like they just helped me to get support on our FMBs and pizzas and the codes here. And the hash, like, they just helped me to get those like Frontier Towers to sponsor to get some banners in here. Okay. Yeah. So thanks for here, and yeah, I will talk about a bit more about this crowded. Okay. So like So basically, like I just got very shocked afterwards because like everyone here is from some Discord, everyone from some GitHub, everyone got to know about Twitter. So like whoever have not used all my open code, all my open agent so far, no. Oh, okay. So like it's a really good chance to learn in the first place, right? So like I think like Q will like briefly like kind of introduce a bit, and then I think like Q will gonna like show up to the next work that he's gonna do in the first place. Yeah, but like basically like Omo, like it's really like kind of amazing history that he got, right? So like you just start. I really remember like you started in the last December, November, late November, or December. And I just got to know about around it was get the start around 100ish, between 112 to 100, I believe so. And after that, yeah, it just went super far. And just everyone's trying to get kind of submit kind of the demands, trying to use those like kind of open source models to use on the production level. But like nobody just try to like tackle down on how to like kind of work with their harnesses to make sure they can just use it at least for this stuff, so that they can just like put those models in the work, right? So like he just really like made amazing work. And after that, there's more than open source. There's a tons of the the repositories you can just see in the GitHub, right? So it's kind of the more kind of becoming a meme for like just creating more. This is my harnesses. It's my like showing off their work in the first place, right? So it's very kind of very interesting movement by myself, and I think you guys also think in that way, right? So I just want to make sure that like people just can't just connect it in the IRL mode. And I would just rather say the next slide, okay? So like we're just getting more bit kind of delayed to our agenda around an hour, but like we just like have to be late in serving the pizza, so it's okay by the way. So I just want to briefly kind of make an intro, and after we just go jumping into the speakers. Okay. Okay. So where's my keynote? Okay. So my one is very short, super short. Okay. So I just want to like celebrate the milestone because like it was just another like, random repository made by Q in South Korea, and we have not like expect such kind of milestone that he gonna get. And I personally met Ale. He is one of the very early sponsors to the OmOCon, and I like just flew away to the UK and then tried to meet him because he's one of the most like kind of Twitter influencers on AI, and he just helped him to get around thousands of stars at the very early days of the OMO. I believe it's around in December, January, I would say, and yeah, he really supported a lot, and I just like randomly kind of like messaged him in the WhatsApp, and what brought you to like support and to like help him to get some tractions in Twitter for like OmOCon in the first place. And we just had some real great conversation at the time, and he's really fan of like trying to experiment more some harnesses at the time, and yeah, he just got kind of helped him to get more traction on that. And after that, like due to the success of OmOCon, like OpenCode, the product itself got more tractions based on these plugins. And then after that, even like there were some legal actions done by Anthropic that happened as well. And also like after that, just like people just getting more into how they use kind of open source models to steer a bit to make sure it works in the first place, right? So I just want to like put kind of like effort in here. Like everyone now talks about harness engineering, right? So like it's kind of becoming more like fancy term these days. Everyone talks about harness. What is harness in the first place, right? So like, when you look at some OpenAI blog, when you look at the Anthropic blog, everyone talks about like harnesses, right? But like its definition is very different. And even like some folks like pundits that claim that the harness engineering is just another prompt engineering which will kind of demise around some months, so even the weeks, because like models getting more getting smaller, and we do not need to make sure to have like playground to steer in the model in the first place, because model itself is super getting talented, right? And everyone like is very. I think like you guys may be kind of always also like excited for waiting for the new. I don't know. So there's some like, rumors going to say that Anthropic want to release a new frontier models other than the Opus. I forgot the name of it. Do you know it? Mugos. Yeah, so true. And well, that's what people are gonna getting sort of ready for it. And well, at least like models getting smaller, and everyone talks about what is the next of the harness engineering. Even like human needs to steer at the model in the first place. And I think like, well, harness engineering was kind of the keyword because like around some of the months well, the code was like kind of the playground for the control plane for the like reality, right? So there's no other things other than code, then you can just fail fast and run fast, and make sure you can just reinforce running in the first place, because they have their own playgrounds, they have their own data, and you have kind of just like kind of virtual cycles to make sure those models and those playgrounds work together. And even some of the pundits claim that other than the foundation model agencies, like who else gonna like have those like virtual cycles so that make sure you have the model, you have the playgrounds, and you run these cycles, right? But these like I do believe so. Still, like there is some kind of the bunch of the needs to want to make sure that you wanna use your open source model, you wanna use your other the specific use cases that the foundation model the foundation model agencies will not open or reveal your specific function in the first place. And in that case, you need to extract some certain intelligence that your OpenAI will not allow likely to do so, or Anthropic will gonna not allow you to do so, right? So you want to extract certain intelligence if according to use cases, or even I don't know, some like just you always have, I think you always let people have their own needs to like kind of like steer some intelligence out of the box, right? Yeah, so itself, like I just want to say, the model is getting more greater, and the model itself is a product itself. And I really love the term. It's like this term is like I think it's coined by I forgot the name of the developer of OpenAI. I forgot the guy who followed me on Twitter. He made the Jason Liu. Jason Liu coined this term, like model itself is a product, and I really like this term. And we're like getting to a more or less scaffolding, more freedom, and well, I believe so. By the way, we're getting to a more domain specific because like we have our different use cases with different clients, so that it's getting more kind of like away from scaffolding the model, but also like just focusing on more domain specific for more steering the model to kind of fit into the specific task oriented, I believe so. Yeah, so that's the thing, and I honestly believe that like we are getting more delegation to the model, and the model itself is run in the background, so that we need more kind of people to be connected. Because like the thing is like, well, we can just dump like all of the software engineering tasks to the model, and we don't even I have never opened up my terminal within weeks, because I just like ask my OpenCloud to like launch their like all my Codex SDKs that me, and I have never opened up terminal in the first place. So in that case, I just want to make sure that people just like focus on more like IRM mode, like getting more connected, getting focused on more like the problems that they should like focus in the first place. So it's kind of more IRM mode that we need the first place that I believe so. So like I just want to like getting more. I don't know like how OmOCon will like be and how we're gonna proceed in the first place, but at least like we just want to make sure that those who are believe in the frontier agents, they can connect it and they can get inspired. And because when you're just looking at some of the conferences, that there are the bunch of like AI conferences out there, but there are really less some chances to gather with the builders who have like dirt their hands with like getting experiments rental like efforts with the models or some harnesses, I would say, right? So I just want to build those like kind of conferences to kind of one of the spiritual reveille for those who believe in the frontier agent. Okay, so one of our like contributor, the Minpeter, like he also like taking some efforts to wanna hold up like OmOCon in the second in the next month. And we're gonna have more chances to bringing this to event with Singapore. I don't know, we're gonna have more chances to connect it in person. So yeah, I'm just like very glad to start this journey in San Francisco. So thanks for coming here today. Yeah, that's my end of slide. Okay. Yeah, so let's just start it on our speakers sessions. So yeah. Just bring it here, and please introduce yourself a bit, and start your speak, okay? Oh, so do you need your lab map to work for yourself?
Or maybe I can just stop about the idea. And
Okay, you can just like put your HTML if you need. Okay.
Cool.
Yeah, cool.
All right, thank you. I did not anticipate that the sun will be falling on so I had the font and the colors and everything.
Yeah.
Is that visible?
You see, definitely made by Codex, right? So when I just like ask the Codex to print the slides, it has the same color, same design outline, right?
Yeah, but is that visible to you guys?
Yeah.
Okay, cool. Sure. Audible now? Audible? Cool. Now, how do I change this? Do you know? Does anyone know?
The slide?
Yeah. Just let me know, man. Something else over there.
Oh my God.
Slide. How to move.
Oh yeah.
Navigate.
Yeah. Just like this one. Okay.
Okay. So this is gonna be very sloppy because I was just fixing this, but slop is the theme of the year, I guess. So, okay, don't judge me. All right, so psyche, and before that, me. Well, I've been trying to solve this problem of how do you represent the digital footprint of the human as a coherent piece for the last 7 years. The last 7 years, I was doing this as a B2B SaaS that did not work out as well. But I'm still on the same mission. I moved to San Francisco, working on the same thing now in new, different fashion. Okay, so that's me. Now, Psyche. What is Psyche? Psyche, well, right now it is a cross-harness agentic memory, and I will explain these words. Please forget the decision traces with coherence because I'm still building it. I do not have the right proof for it, but some data. Okay. What do I mean by cross-harness and agentic memory? Well, this is a very specific problem that I'm trying to solve in the whole landscape of memory. And this is more user-facing memory. Okay, so general landscape, and I think someone else is going to talk about memory in depth later on, so I'm just going to keep it short here. You're familiar with these names: Mem0, Memorex is a new one, Supermemory, very controversial, Letta, Mastra. Mastra was the one that actually changed the game for memory because they were the first one who removed vector databases entirely and is scoring 98% on long mem eval, which was the standard benchmark. And yeah, this is where, this was, I think, last November or October, this is where things really changed. Now, different approaches that you see: temporal knowledge graph, Zeb Graffiti, they did really good at it. Knowledge graphs, you see that. And then there is, well, let's just say that a lot of new teams and a lot of new research, if you follow the work of Jeff Kloon, Alma, they are actually moving beyond deterministic definitions of how do agents actually remember, right? Because language is way more denser, coherent, etc. I, for the last 1.5 years, had been working on knowledge graphs without the strict ontology, generated ontology, domain-based, decided by the LLM. I was working, and I put this together with a vector DB straight out of the box from Neo4j. It works, but it's really hard to actually make it work properly. I'll tell you why, and then I have some links where you can actually go and read the data and the receipts for my experiments. But mainly, you will have a cap there at around 60 to 70% for even the best benchmarks, whether you use Beam or whether you use long mem eval, mainly because, well, the problem is determinism versus non-determinism, and graphs don't actually capture the value properly. We are using the graphs incorrectly. There is a better way to use graphs, and I was experimenting with that over the last 2 to 3 weeks. Well, a month now, I guess. Okay. I don't know how much of this is visible. Like I said, knowledge graphs, that's one thing. That's the way to structure the information. Then there's hook-driven observation, which is getting very popular in non-academic memory systems, or let's just say more practical and useful memory systems. So you have hooks across different harnesses, tool calls, what files were read, what the results were, and then you build a memory system out of that. Spacebot, I think, and Memorex. Memorex is the one that a lot of my friends are actually recommending and using. So there's that. And then, of course, there are agent-managed memories. So what the recent controversy with supermemory is that they threw like a bunch of agents on a very simple data set, and then they proved that this works, right? And I think they created the controversy for a very good reason, because I think we need to measure what a good memory design system is in better terms, and probably take inspiration from neuroscience and physics. Hand wavy, but I'm just going to refer inside Geoffrey Hinton. Okay. Context compression, very good thing happening these days. Morph Labs, and who else? Yesterday, I think, right? Someone released a model. Was it Cohere or one of those vector DB companies? Sorry? Cohere, right? Yes, the search model came out, I think, day before yesterday. Context search model. whether it was Quadrant or one of these companies that used to be a vector DB company, but then they just released a model. Anyway, the point is that when you work with agentic harnesses, there are so many same searches. You search the same files again and again. You explore the code in many different ways. OmOCon code solution to this was very good because they were using CrocFast and Gemini Flash, I think, for searches. Really fast, really cheap, and much better than, let's just say, using any cloud model, not even Haiku. So I think they trained a 20 billion parameter model on top of the OpenAI one and focused primarily on, through a session, the searches that are happening, how do you preserve them, and how do you do it faster, right? The relevant files which are in the session, etc. So that's context compression, many other angles to it. We're all discovering it on the go. File handoff. Well, this was actually continuation because this is all Claude generated. So please forgive Claude. File handoff essentially is continuation in terms of whether you can call it context, compression, compaction, so many different words. AMCode took a call on having no compaction entirely. Slate is a new agentic harness that has come out, and I've spoken to the guys, tried it out. Slate's the entire thesis is that one session is the end all of it, so there is no second session, and so you can spend like 200 million tokens on the same session and keep working on it. So there are different strategies on how do you deal with memory and what memory really means. The slice that we work on, or what I'm focusing on, right? And it is interesting mainly, which is why I chose it, because I am not trying to define the memory for, let's say, a human as a process in an organization. So not memory for a product manager who's using Slack and a bunch of 10 other tools, not memory for a healthcare worker. I think those problems are solved very well by people who actually understand the domains well, those who design the ontologies and the taxonomy very well, and they would have a better idea of how to design those memories, and mix of vector DBs, knowledge graphs would actually work there. The problem that I'm focusing on is also not individual user memory in terms of the agentic harnesses that they use. So I'm not saying that my memory will be better memory than Claude Code's memory, or my memory is a better memory than, let's say, OmOCon Code's memory implementation. I am focusing on just one specific, very small specific part in this entire equation. I use concurrently at least like 3 or 4 different Claude Code sessions, 2 OmOCon Code sessions, which essentially implies there are 12 agents. I try a bunch of different harnesses just for, fidgeting while I'm actually working on my real project. I have to fidget, I have to experiment, research. So I try Hermes agent. Then Codex is really good at, whooping my ass and giving me really good architectural reviews. So Codex is also on. And then, ecosystem changes, industry changes. You want to keep up. So I have some data to show, but the fragmentation is very strong in my day-to-day living life. So all of these harnesses have built the best memory system for their own harness. But me as an individual and my collective life is a very open-ended question, right? It is not defined in, let's say, one code base or even 3 repos. It's just life, right? So many more things beyond just work, beyond just fidgeting, health and all that, relationships. So, yeah, gotta manage with Claude, man. With this level of fragmentation and all tools really designing really good memory, we still need a coherent layer so that everyone is aware, or every agent rather, is aware of every other agent, and there is no narrative drifts. There are no decision drifts, because most of the time it is not me deciding, hey, I'll use this tag, and then documenting it in the code, which is where the problems emerge. That's not where the problems emerge. Problems emerge when I have a vision, which is very obscure and vague, but it defines essentially pretty much everything about what me and my company and my tools are going to do. Let's just say something very simple, and I'm sure this is an experience that everyone has had. LLM forward design. What does that imply? I keep repeating this to my own systems, whichever harnesses these are, because they are trained on previous data. So they naturally will design, regular expression-based heuristics, random threshold-based designs, numbers that don't make sense, because they don't understand most of the reasoning is already in language now, right? So they are not trained to work that way. But I keep repeating this phrase, LLM first design. What does it mean, right? It's a concept that is shared between me and my machine. That is all. It has no real meaning in the industry as such, no real taxonomy, right? So we will all develop our own ways. Some will judge you and call it psychosis. You push through it. But the point is that your AI has to figure out what your concepts, your world, your phenomenology, basically your concepts, right? What do they mean? How do you think? How do you work? All that. So that's the layer that I'm working on. Okay, what federation looks like, I don't know if you can see this, but Cloud Code Codex, basically the same yapping I did. Cloud Code Codex, Open Code, all of that bounded by Psyche. Psyche is the one, the engine that makes sure that all of them are coherent and stable together. Psyche is not going to interrupt with Cloud Code's memory system. What federation here means is that Psyche introduces federation amongst these isolated agentic harnesses so that they can work together. Psyche does not aim to be a harness that the user uses. It is only meant for agents, and it is meant to run ambiently in the background. So you can keep using your tools. You put Psyche on, it'll just make things better and cheaper, more likely, right? So that's the federation architecture. Fragmentation problem, this did not render correctly, but this is like my 1 month data. It did not render correctly, but you can see how many parallel sessions I go through at a time, and the Claude line is entirely null right now, but there's a lot of Claude activity happening there. But you can pick any day at any time, and then there's more stuff happening there. I don't know if you can read, but I'll share the link with you guys. You can check it out, and we can discuss more. Point is, this was the fragmentation that I was talking about happening in real time.
Is that showing that OpenCode is more fragmented than?
That's just my usage.
Oh, okay.
That's my usage. So this is 1 month data, and in between, I use Claude more. It's not showing up here. OpenCode usage was a lot more for me because I was using all my OpenCode. Codex usage, early January, good enough. Well, it's not there in this data now, but I'm using it again now. So that was a fragment. There was Hermes agent in there. That's that. But I think the important thing here is that just within one codex, I can have multiple sessions, and each session implies anything depending on who you are and what you do, right? One session can carry 3 or 4 different human intents, right? Earlier, maybe I was researching, and then I was putting that research into nice infographics. So suddenly that research problem changed into marketing problem in the same session, right? So there is no deterministic way to actually map this.
Sure.
And I don't really even want to develop some boundaries that, hey, this session was about research and then it was about marketing, etc. And yeah, so that was the fragmentation across all the different tools that I use on my system. Now that the fragmentation problem has been established, why do the current memory systems, or let's just say the current approach to how do we even say that this system is good, it's just wrong, right? So the benchmarks, if you just look at, I don't know, have you guys actually read and gone through the data set in any of these benchmarks? Like the popular one is long mem eval. Have you gone through it? Beam is really popular these days, no? It's just random synthesized data from the way, no one talks like this because LLMs also don't talk like this. This was back from 2023, right? So you put a simple question, hey, I'm trying to cook this thing, and then LLM will generate like, a long ass recipe. No one talks like that. LLMs don't talk like that, right? It's very in the moment driven. It's very different. This data is not at all representative of anything remotely personalization. The only things that the only stuff that they actually check is how efficient one system is on retrieval versus another system. But retrieval is not the memory problem, is what I keep saying, right? The memory problem is a modeling problem. So again, which is why I don't like these benchmarks, but just to actually give you some data on what real benchmark is like, right? So my data, I just call it n equal to 1, right? The point here is that within 60 MB of agentic slop, my data is just 38 kilobytes, right? And that is my real human intent. Because what these data sets consider for their memory system, it's a very 50-50 divide. I don't know if this slide shows it. Well, it's not this one. Well, okay, so if you go through the benchmark data sets, you'll see that it's a conversation, turn-by-turn conversation. You say something, I say something, right? But that's not how we talk. What really happens is the ratio is about, it's not 1800. Well, it's not 1800, but it's somewhere up in 500, 600, which implies that, counting all your sessions, sub-sessions, parent session, tool calls, sub-agent calls, one human turn implies some 200, 300 agent turns, right? Depending on how you're using it and how much you're using it. So number one, that's the first big asymmetry and how these benchmarks are not actually comparing anything real. Number two, oh yeah, well, the ratio was actually here. So the human share is 4%. In the benchmarks, it's 50%, right? That's not how it goes. Your human share in the data is 4%, number one. But most of the decision making, the actual architectural decision, the logic of it, how does a certain implication in your work actually translate into a certain commit, all of that data is in this 50% agentic mess, right? So that's what we have to recover and figure out and map how this changed, right? Many other things that happen, the way meta evolves, new tools come, right? These benchmarks and eval sets are not actually designed for any of that data. So I guess everyone goes through this problem and we are trying to solve this in our own way. Content range, very standard chat in your benchmarks, but I use mic mostly, right? I don't even type anymore, right? So I go on a long 2 or 3 minute yapping session and hope that my AI gets it, right? So it's like so many characters. And again, the benchmark is not testing for that. These benchmarks are not testing for that. My real data looks very different. Source extension, not really a very strong point, but the point again being that many sources instead of just one, and some sources might drop. But the same story of your life will continue. You'll still work on the same project, but the source would have stopped. So again, you cannot bring in determinism here. Same point, repeated again, when deterministic categories meet real data. I don't know if some examples are good. So LLM first design, I think I talked about it, 9-hour silence thing. And yeah, so these benchmarks, many of these are laid out as, let's just say, one-on-one session between me and AI over 20, 25 days. But there's no sense of continuity there. What time, right? Time zone or time, etc. And there's so many things that actually solve your experience because you are asking AI, or at least the way I talk to my AI, I'm like, the run that we did 2 weeks back, right? Or the run that or the bug that we found last Sunday, or some things like that, right? It's very conceptual, very personalized that way. So the AI has to be able to figure out that these benchmarks don't consider time as an essential object at all. Now, this particular slide was actually about putting the same argument of deterministic categorization in designing this particular aspect of memory versus, do I have time? Am I running out of time? Okay, cool. That versus, just keep going. Yeah, so how, let's just say one frustration, right? That beam benchmark was high, and then what happened? And the audits weren't all that, right? It's just my natural frustration and expression. And if you look at, let's say, the current tools, they do not have any place for messages or intents like that. For example, if you take Spacebot or Memorex, they are still designing a memory harness for coding. So they will have 7 or 8 different ontologies, like observation was made, the logs were made, this was the stack that was decided, there was a contradiction here. But again, you're still doing the same thing. You are making categories so that the LLM will naturally fit into it, right? And so I think my frustration here was not an observation, it was not a log, it's just me naturally talking to my AI, but that implies so many things in terms of what the ontology for coding should be. It could be a design decision, it could be so many things. So, well, let's stop again. How do you do it?
Sorry. So you also want to do a demo on that?
No, I just want to move the slider.
Move slide on. Okay, just doing this. Yeah.
Cool. All right, okay. Hand wavy stuff now. So Geoffrey Hinton and basically all neuroscience today is converging on this idea that memory is a learned space. It seems very simple when you say it that way, but what they're saying is that the Turing categorization, which I think was popularized a lot last year, episodic memory, semantic memory, short-term, long-term, this categorization was designed in 1960s by a psychologist, right? It is not real neuroscience in any form or way. It's not a separate standard model of what memory even is. Memory is not retrieval again. Memory is movement, memory is time, memory is energy efficiency. So Geoffrey Hinton's work was essentially about that. To be very, very hand-wavy, what he's saying is that you make a memory map, and your memory map, or let's just say your memory palace, changes with time, so that the agent actually finds it easy to navigate however you as a person are changing, right? So again, memory as an architecture has to be stateful, but it does not have to be static and should not be static, okay? So what does that imply again in our debate in determinism versus non-determinism? For this specific scenario, it implies that we learn or let our memory system learn stable attractors. And stable attractors essentially means that certain phrases, let's say, or certain terms or certain ideas that I'm dealing with within that week, which probably would not be relevant 2 weeks down the line, right? And so just let these attractors emerge as I'm working and work with these, and the determinism finds its proxy in these stable attractors rather than us having to design and curate this exploding information. So how do you get to that? Well, first you have to let a lot of chaos happen. The kind of stable attractors that I get, I don't even remember what example is this. Okay, yeah, these are just, let's just say search terms, which my agent in that particular period of work found relevant, right? These were these stable attractors for me: competitor intelligence, doc cleanup, agent monitoring, desire, retrieval pipeline debug, release readiness. These are not categories that you can define, but the agent developed these as places where it was linking more and more memories around, because that's where most of my discussion and information was flowing around. So what I'm trying to show here is that, well, I did not put it very well, but if you look at Spacebot and how Spacebot is doing their categorization, every attractor is assuming at least 6, 4, 5, 4, 3 different categories. So this space is very fuzzy. It is not, again, logs, observations, etc., right? Conflicts, commits, diffs, no. And search entropy, right? So it has to be efficient. The goal here is that you have to have bare minimum search. Your agent should always be active. Your memory should always be active. I'll show you the architecture first, but I'll tell you what my goal is. I'll be really happy if no agent ever has to make a search call when you're using it, right? And all the memory is already available. Okay, how does the architecture work now? All the different harnesses, there's an observe layer. Observe layer is basically a factory pattern. Shout out to guys at Super Tools. They taught me how to do it properly. But basically, I am just giving certain instructions, and I'm saying that you have to go and speak to a harness, not even implying what kind of harness it is, and go and read the documentation of the harness, figure out where does the harness store its own data, in what shape and form, and then actually develop adapters in real time by understanding where the user has set up their harnesses. Very simple. It is not working exactly the way I intended to do, but it works very well, to be honest, compared to me hand designing these adapters. So there's a factory, it will plug in all this data, it will get in all this data, and then it will, the one single source of truth for any memory, or if you are in this spirituality, right? The only source of truth is time, right? So you have to have a one immutable ledger, first of all, and only that is the one thing that we keep deterministic here, and everything else around it is morphable, learnable space. So a ledger where all the events, because UUID naturally gives you the time and order, so you just stick it there, and make sure that you don't have concurrency issues as you're putting it there. So I'm not a great backend engineer, forgive me. The events.db is where all the external world data is coming in, but also Psyche's own logs of its own working is all going there to events.db. This, and again, sandboxing is a concept here that I'm learning. I would love to learn from you, but point here is events.db does not get touched by the agent at all. Psyche.db inside Psyche runtime, which works on Pi. Psyche.db is the database for the agent. This is a free space for the agent to work in. Mimics.md. So if this is a free space, and I'll give you some reasoning behind why I chose this particular architecture, but if this is the morphable space, then we need a router. In neuroscience, it's a hippocampus, right? Hippocampal index, basically a router, very simple language. I did not want to call it index, and I wanted to call it mimics for no good reason, but it's a router. What does a router do? I would have shown you, but maybe I'll show it to you later. Okay, so Psyche.db, very paradoxical. It is a SQLite database, but it has a graph on top of it. Why do we want to do that? Again, I think a lot of this is my own kind of frustration, and I want to be like a, show it to you, but it's more like you need graphs not for this particular context. You do need graphs, but you do not need graphs for, let's say, centrality computation or any of those really cool, great, beautiful algorithms that we have for graph. You need graph only because you need spatial proximity for the agent to understand what stories of this user are relevant to what stories, other stories of the same user. And so the graph is a sparse graph on top of a relational database. Relational database because, again, it's an experiment. Agents are really fast with just BM25, really easy, and you can take the same DB, put it on your browser, move it across different devices. So it's no orchestration, no graph setup, nothing. It's really simple. And also because, like I said, right, most of the reasoning, the evaluation metrics, the different reciprocal rank, whatever you design, doesn't even matter, right? Because agents can reason better. You don't have to design this. You don't have to design these re-ranking pipelines at all, right? It's so frustrating to do it in graphs, or at least with language data. So the agent will do it. Mimics is a router. PsycheDB is the relational DB with a free graph space. When I say free, and I'm implying free because it's not an acyclic graph. There is no opinions there. It's just a graph. Okay, so what does it look like? Please don't mind whatever Claude put in here in between. If you can see it, if you don't, amazing. PsycheDB, like I said, free graph space. Each of these are just basically relational DB stacked memories. All of these, just think of them as markdowns, right? The agent is deciding which ones are in proximity to each other. And sparsity as a measure is not something that I'm controlling for yet, because there's so many other questions I have to answer. But yes, that will be a thing I'll control for later. Mimics, like I said, is a router. So the interesting things that happen here, right? Because I'm following the JPA and the hyperagent lineage of research and trying to implement it. So the interesting thing that came out in one of my mini ablations that I did was I gave it a free graph space, and I gave it no other rules except for just telling it that you are supposed to be a good memory. And you have to map memory better. So that word was important, map, right? What it did was, on my data, for 11 to 12 days, it was just going through these boom crash cycles of having the context expanded, and a great crash, then the context would expand, because it did not know what mimics was supposed to be. And none of my instructions were explicit in the sense that this is what you're supposed to do. I was trying to vaguely push it in that direction by using the word map. What it did after 11th or 12th day is that it had gone through 3 cycles of this boom crash, context compression, explosion, compression. After the 3rd cycle, it started putting hyperlinks in the mimics, right? So yeah, you could say that I could have told it from day one, put pointers there. It would have worked, right? The point here is that I did not. And the agent still finds ways. And this, I will tell you, is a very, very controlled environment. Like, I'm using big words like JPA and all that, right? But it is basically a simple loop where each turn is able to look at its own logs, right? That is the only self-scaffolding that is real right now. I have experimented with uh, just having the agent change its own synthesis prompt, and it became, I don't want to claim anything. Anyway, it became very obsessive about its own logs for some reason. Now, uh, yeah, so the Memex, right? So the Memex is this router, and my intent for Memex is that it has to be a human and agent readable router together. Why? Because the human will always be the first judge of anything, whether things are going the right direction or not, the decisions that I'm going through. The daemon will keep updating this, keep synthesizing and keep updating the router or the Memex every 15 minutes. I can play with different frequencies here. 15 minutes, right? It's good enough. So what that does is that all my other agents are now in sync with each other by default, and they have router or basically these hyperlinks to go and check out different memories. And they can, the distribution for Psyche is just a simple Psyche ask, but the agent can actually go through the DBs as well if they want to, as in your other agents. And Psyche ask is just, just put a language query to Psyche. Psyche has its own mapping. It'll figure out and give you the answer. I have, this is the same example again, but like I said, right, LLM first is just a word that I use personally, right? But it implies a design, a debugging criteria, a competitive argument, blah, blah, okay. Same data, different constraints. What does it mean? This was, yeah, the pointer story that I told you. The numbers, don't trust those numbers because they're roughly in the same range, but again, it's not something I would claim or publish. I intentionally did not fix this slide because I thought I could show you a demo, right? But I would have shown you my self-scaffolding memory harness. Is there a way I can show?
Yeah.
Great. Can you hold this? Okay. I'll take your time. Visible? Yeah, visible. Cool. Oh, here. No, I cannot click.
Yeah.
Work. I'm not able to click anything now. Choose.
Yeah, that's all. That's all.
I think we could come up here. Just come. The reason I cannot go to
Excited for almost.
Yeah.
I think it's located right there.
Okay, this is just a simple visualization for the different experiments. The point is that this is the synthesis prompt. I wanted to go with that approach that the HyperAgents paper did, which is start with a zero minimal prompt. And I'm experimenting with it because my loop is closed, but not closed in a, let's say, knowledge transfer way. The agent can learn only for those particular turns in that loop, but cannot actually change the synthesis prompt itself, right? So the true learning or true evolution can only be measured when that happens, but I'm not doing it because I'm the one in control right now. I want to see how it evolves and behaves. So one thing that I had to do always was, because I do not know how to build a proper sandbox, yet I had to put these things in there because, like I said, the agent gets really obsessive about its own usage and tries to develop patterns and tools for that. Anyway, so Memex is this document. This is my anyone data for just 1 month. My entire data is spread across 7 to 8 months, but I'm just working with this one window. Okay, so the way mimics is, right, and you can see everything here, characters, not really relevant. Just look at the mimics. Okay, day two, day three, right? It is evolving. It is a very broad, high-level description, but it started developing these hyperlinks, right? And hashline. I think someone works on hashline here, and I think that is something that I wanted to try because this is a hyperlink. It is supposed to be deterministic, but it is generated. So even just one piece missing here would screw up everything. So it starts developing these routers, right? So all of these are different memories. How do they look like? Okay, right? So each memory, first day, let's say, this is just one memory, okay? And then it evolves uh, what is the active memory, the linked memory. Some memories get superseded. The lighter shades are the one which got superseded, uh, and the active ones are still the ones, which is the focus of the agent primarily. Uh, yeah, basically, okay. Point here is that over 1 month, these different memory blocks came out, and again, relational database. But I'm developing 3 links here, just so that the agent has proximity for what lies in different sets. So this is a harness I get to see across all the evolution, right? What is the agent thinking? What calls did it make? It's just easier to see it this way, but the point is that this again is making very good data for the agent to then look at itself and develop better functions for itself. So hyperlink was one. In a very primitive iteration of this previously, the agent was able to make, because I had put in human readable as a thing there, the agent was able to, not able to, but more like the agent stabilized on giving me these Kanban board like emojis so that I can distinguish between what are my to-dos, among which threads and everything, and I did not have to manage or maintain it. Some more complex limits that did come out. But yeah, doing things like this helps. I'm still learning. I'm discovering, right, how I do not want to let the hyper agent free, because then it's just stupid computation for no reason. So I want to figure out how does it start containing itself. I'm just going to finish my talk now. I think the most important question amongst all this, I described to you the different evals, how they work, why they don't work, what my system even is, how it will optimize itself. But I still do not have answer to the question: how do you design the eval, right? What does eval even mean today? Because even if you look at the hyperagent speaker, which is barely a week old, you are seeing them designing a very hyper intelligent, self-involving agent, but the eval is still a very static set over which they go through 2 or 3 iterations to say that, okay, it survived and it learned across iterations. But what I want to do is to actually make an agentic eval. So the judge, and we all have a judge inside us, so I want to put that concept inside the agent as well. Can the agent have a lagging or perhaps a leading judge, which is always working with the memory agent as its own shadow and kind of optimizing it, right? So hand wavy idea, I do not have answers for how do you make a judge for a system that changes dynamically. And yeah, because this is a n equal to 1 problem, every human is different, and I want to see and work with other humans. I have like 3 or 4 other people who are willing to put their own data in this and work together and figure out how my memory architecture, for example, looks different from yours, everyone else. So yeah, please connect with me. I would love to. This is an interesting problem. How do agents understand a different human? That's about it. The bigger question: how do you design evals? Yeah, that's it.
Any questions?
Questions? Yeah, questions. Sorry. Yeah.
Have you considered using Obsidian as a means of storage, because it supports graphs directly, including like backlinks?
Yeah, it does. It does.
Yeah.
Zettelkasten. So that framework is Zettelkasten, right? So what you do is, I was working with Obsidian
Okay.
until last year. It's very heavy as a framework,
Sure.
but which is why I chose SQLite. But the other thing that Obsidian assumes, which my personal opinion is not leaning forward. I mean, I don't care about that part anymore. Is that they design backlinking through tags,
Yeah.
which again is deterministic. Let the agent do it,
Okay.
right? Because not only we will probably reduce our own effort into designing these categories, right? I am against category theory, by the way, but not only will that happen, but we will actually get to see in what level can the agent represent the complexity of a flowing free human, right?
Yeah.
So that's why I was against the Zettelkasten framework, like do not links. Otherwise, Obsidian beautiful. I used to use it. I'm an Obsidian head. Yeah. Any other questions? Yeah.
Yeah, I think I lost at some point. As I heard that your memory system is kind of hardness neutral. It's like interface of those harnesses are created, or how are they all integrated? How come they can be
So the pattern that I'm going for is federation in terms of memory. I am not going to change any harnesses implementation of their memory.
Yeah.
The devs know best, right? But where the user is concerned, and me as a user, I'm using 5 harnesses across, let's say, 12 sessions concurrently,
Yeah.
right? At that point, I need to know, or I need to have a, let's just say, a cache memory, which is better for all the different harnesses in their memory. So the way I introduce federation is to say, I will learn from your memory for my own sake and for every other agent's sake. You can choose to ask me questions as well, like you as OmOCon code. You can choose to ask Psyche questions. You can choose to rely on Psyche, right? Etc. But yeah, that's the intention here. I do not want to replace any memory design for any other developer or their piece. This is a different thing. It's like a cache sitting here, doing it locally, keeping all my data local. Did I answer your question?
Yeah.
Okay. More questions, please.
Thank
All
you.
right. Okay.
Yeah, thank you very much.
Yeah, so it's okay. Yeah. Yeah, so next up, I will just move off to the panel talk. So I'm inviting the Q and Billman and then Peter and the Richard. Yay, cool. So like set up just that. Yeah, that's one another shares I place. Oh, sorry. Yeah, gotcha. We need one another. Yeah, cool. Oh yeah. Q. You just take it here. We need one more chair. One more chair. Yeah, I see it. Yeah, so sure. Okay. So this is the panel pie just invites 3 like maintainers and one another from the engineering team and engineering leader. So like, can you just like introduce a bit starting from it?
Yeah, I'm a maintainer of OMC and OMX, which stands for All My Cloud Code and All My Codex. As you know, All My Open Code is a great harness, and I bridged it to Cloud Code and Codex, and it is not a single fork anymore. I will talk about it later. Yeah. Hi, I'm Chu. The OMO thing stands for on my own code. I made it, so really thankfully hosted this event, and I'm creating the best agent harnesses I wrote on the GitHub repository, and grateful to be here.
Hello, my name is Doong Min, aka Dean Peters. So I'm one of the my open agent maintainer, and actually I'm not ready for introduce myself. So yeah.
That's okay. I hope this stretches all the way around. Let's do this. Okay. Hey, I'm Richard, co-founder and CTO of Doe. Doe is a multi-agent orchestration platform to make it easier for businesses like law firms or dental practices, etc., traditional legacy businesses in the US to spin up hundreds of agents using thousands of tools and are resilient across many outs. And this is just as easy as writing a prompt and it goes on and does the work for you. We were part of the YC Summer 2025 batch. Just happy to be here. Thank you for the invitation. Yeah. Bye.
Yeah. So I have to, we have to do this every time?
Okay, so basically, I think I will give like by myself to you.
Okay.
Like you don't have to get a sequential manner. Okay. Yeah. So like there's a student or from my friend and which I met in the some 2 years ago maybe in some random interview. So yeah, thanks for like sharing out there. Yeah. So like I think like those are just the core builders that they all are working with an agent. So like, I just want to like give a quick question. Like everyone's talking about hardness, and what's your like definition of hardness, and what's your kind of pretty minimal prerequisites to be called as hardness? What's your take about this? Anyone? Yeah.
I can answer that. I think nowadays the agent can be part of itself and simple bash tool and task tool can be a minimum bar for harness, but for proper steering, you would need hooks and skills. I think that's all. You cannot, you should not really complicate what harnesses is. Yeah.
I actually don't like the word of harness, to be honest. I know that this sound might weird, but like, you know, it's really simple when it comes to build something what we call harness these days. It's all a while loop and just tool calling and everything. Just, you know, if you can prompt and if agents can have tools to execute, I think that's harness.
This is kind of awkward. I'm just fundamentally going to reiterate that I think the minimum viable thing for a harness is quite literally an iteration loop, and not necessarily the tools themselves. So that's how I would summarize it.
Well, I think harness is the same opinion to what's your name? So I think agents root to schema and to execution, and then it's over.
Okay. So like, well, I think like everyone talks like talks can be called as honest, called as harness. Like well, the people don't think like well, one of the reasons why we use like harness. So okay, so I just don't want to adopt the APIs to the Anthropic folks. So I just want to like reduce the tokens that I use, and so I just want to use the Chinese models, but actually Chinese models are not like capable of that much. So like, oh, I love those like using just like harness stuff, and it works pretty well, right? So like, other than that of cases, so what's your predictions of like harness engineering? So like, other than that of like using kind of like open source agent models, are there anything that you can find something fruitful to work with scaffolding?
This can be a simple quick spoiler of the presentation that I had in the future. Like two sessions later, but like I think there's pretty much thing that we can do. Harness engineering is pretty long. Like thinking of those techniques that recently introduced, like adversarial agents that I have introduced in the Atlas, like on my open code. Everybody's doing it, and Anthropic recently posted a post about like long running harnesses. They're actually talking about like the Atlas actually. If you look at those factory droids, they have released the droid missions and everything. So I think those gaps or modes or the future roadmaps or whatever. I think I can say that harness engineering is kind of complicated problem. I know like everybody recently started to talking about harness engineering these days, but like as a person who started those kind of stuff like 7 to 8 months ago, like I honestly don't see any more advances that gonna make dramatically better like I've done before. Yeah, I'm not sure about it.
Actually, all my Cloud Code has all features and all orchestration schemas that Cloud Code is now trying to introduce. Back 90 days ago, and I secured like 50K stars on GitHub with that. And I completely agree with you that harness engineering is almost done. We can do, we did whatever we could do, and I think that there will be the next pages about harness engineering, what AI orchestration system and AI operating system should do, and Q and I will speak about that in later sessions again.
Like all other things, like we use for other than that of like hooks or kind of skills, like we still need some memory layers and like lots of folks like have some different approaches to attack development. So like in that manner, we can like say this kind of part of the harnesses. And what do you think about kind of those memory layers? Like is it we will continue work like just create the own model files with just have them structured data down, or like still like having those like some folks that asked in the first session that there's mentioned about graph stuff as well. And then, like what kinds of the projects for you gonna have some memory layers in the first place? Do you have any ideas?
To give people some context, so a lot of the work that we do in orchestrating the agent system is that we actually actively sort of many agents and have a context share between agents themselves. We found it to be far more efficient given like infrastructure constraints at the moment, right? So for us, it's not just about storing things on the .md files or having them on a file system, but also equipping them with the tools to actually access specific elements of that memory itself. And we leverage that significantly in our memory architecture, and it's partly why we're so powerful. Other labs, OpenAI, Anthropic, even Cursor, and Devon, leverage the file system approach a lot. So that's something that I would advise people to explore a lot more.
Actually, yesterday, as you know, Jeffrey Huntley, the creator of Laravel, is on South Korea Rotterdam, and I spoke to him just before my flight taking my flight to San Francisco, and I really totally agreed with him with memory architecture. The memory architecture is just about how we bridge traditional computer science kind of memory and neurological memory into agentic memories. For instance, the Jeffers view for the sub-agent was to treat as a heap, and the orchestrator that orchestrates between sub-agents is a heap orchestrator, aka processes, and OS is a layer that grabs many processes. So that's kind of short-term memory part, and the long-term memory part is really similar to neurological brain. I really restructured my open cloud memory a lot. I don't use RHs, I don't use embeddings, I only use file system, but the retriever and the pointer system is quite advanced, and all the idea was coming from the neurological science, actually.
If I'm not remembering, if I'm remembering correctly, as I heard, like he's actually making the operating system just for doing some agent orchestration, right?
I am not sure Jeffrey will be happy to say this, but
I might have mistakes.
yeah, sure. Forget it. Yeah, please. But he's doing something funny regarding memories, and he also said that WARF is just about memories. WARF is just a meme, and I was just wanna talk to people about agentic memory systems. WARF is about memory. Context is a memory. Everything is a memory. So I guess that makes my point. Yeah.
Okay, so in that case, like when like you're working with more than agents, like we're like having a bunch of the flux of the memories that we need to take in the first place. And but there are some like when I did some interviews in my YouTube live stream with the Q and the development, they have some bit of agreement of how many agents, and how many the systems, the complexity that we need to have in the first place. Like only a small number of agents is kind of like it kind of very narrow, but we have more than thousands of agents that is really difficult to orchestrate in the first place. So like those kinds of like considerations that you need to be still to take into account, or at least we need to go more model based. We do not need to have those like composing the multiple agents with the different ones. What do you think about that? And how many agents we need to have, and how many for sort of the strategic market, and as model goes by, we do not need to like orchestrate it in the first place. So what do you think about it?
Yeah, so that's a good question. I mean, it's very much like context dependent. So it depends on the query that or prompt that the user provides in the first place. In our first principle approach in building the multi-agent architecture, one of the things we ran into is that like an agent could possibly only use like a couple of handful of tools, like 3-4 tools effectively. And that's why we sort of expanded across to use multiple sub-agents and multi-agent architecture. I think I think part of your question there was about how we actually orchestrate the different agents.
Yeah, so if we have more agents, we need to orchestrate the first place, right?
Yeah.
Yeah.
And also how it ties into our models that way.
Yeah, like
So
how many?
So when I got a chance to talk with Greg Brockman from OpenAI, one of the things that he said was, even at OpenAI, they take a naive approach. They assume that they haven't hit a wall yet, and as a consequence of that, they just dump a huge amount of compute, and they continue to push compute, right? And they've yet to see a limitation to that approach. And so they're very much like a naive approach first attempt, and then once you hit a wall, then build around and create a more complex system. And what we're seeing as a consequence of that on the sort of model behavior element is one instance is like the model themselves are much better at following instructions now. But at the same time, it means that optionality also increases, right? So, like fundamentally, I think if we just rely on this naive constraint or like naive assumption that the systems will continue to improve, the models will continue to improve, orchestration will become easier over time, and we don't have to build as much effectively or overcomplicate the mechanism. Well, that's like at least like our assumption here.
What do you think here?
I don't know actually understood it quite right, but like in terms of multi-agents, like if you have to design it or if you have to work with it, if you don't have any desires to make a sub-agent or multi-agents, if you don't feel that one agent is doing pretty alright, you don't have to. If one agent is doing great, you don't have to create multi-agents, right? Of course, obviously. So the question, I mean the answer of the question would be like, it depends on the task, and you'll know the answer because you have to. You'll be the one who had to tackle with those tasks, and like it depends a lot on the tasks that you're gonna work with and you have worked on with.
Okay, so in that sense, like asking people expect when it comes to context, when it comes to the foundation model, the provider, they have the model, they have their own CLI tools, and they have own products, and they have some virtual cycles to reinforce itself. So in that case, are there any other products, or are there any sort of rooms for non model provider, third party can tackle onto it? For example, when it comes to courses, they are all kind of it's Twitter by just doing our own stuff based on their key mutation. Well, that's the thing, right? And even that can work a bit because it's kind of the steering the model afterwards with the kind of decently
train the model in the first place, right? So like, do you still believe that are there any other rooms for non-model providers can provide kind of some products that can work with the model just even better than the foundation model providers?
It's like they cannot have best harnesses because they are actually a model provider. It's really ironic because they are not really incentivized to make a product that makes massive parallel too close to the providers. It's an infrastructure disaster, right? So it's a kind of relationship with car manufacturers and car tuners. So car manufacturers provide cars that goes up to 300 miles, but they lock it in production about like 150, right? Just like that. OmOCon cloud code is a cloud code plugin, but it boosts up cloud code in a way that Anthropic will never do because they have a model provider. But as you know, if you tune a car properly, it goes much faster. That's what I and Q and every harness engineers are doing.
I think fundamentally there's a lot of work to still be done in the infrastructure layer for agent orchestration. I mean, one thing is how can we more easily set up containers for agents and sub-agents to run it, right? Currently, you can maybe run an AWS Lambda function, right? They're short-lived, 15 minutes long, and cold start problems, etc. You might want to use durable objects from Cloudflare, for example, but they're also super expensive. So there's a lot of problems around this area that I think could be solved, and there's definitely a gap in the market to solve for it. Someone in this room is working on it at the moment. I don't know if I can still go.
I'm actually a fan for what Damon has said before. Like his main job is just because his main job is concentrated, and he actually, I actually need to shout out of him a lot because he said this about a year ago that LLMs are smarter than you think, and you have to make them to think and research autonomously. So that is his idea that told me like a year ago, and he showed me his own project called ViveCunt, and he even bought a new house just because of this project. And like I got so many great ideas to take from his ViveCunt project, and I created my own coding harnesses. And one thing that is important thing that he said to me is that you don't have to make a generalized harness. You have to make a specialized harness because that's what everybody else is not doing it. Because and like if you can make some kind of specialized system for something, and there's no way to beat some kind of generalized harness or system can beat them. So yeah, that's basically what I'm thinking.
So I don't know. I followed the whole context, but so I want to add my opinion to Balman said. He said the model provider doesn't do that making models too cold, like the sub-agent orchestration much larger, bigger, the massive too cold. But I think they if they do make a massive too cold, so they can earn to the LLM users, so they 이렇게 해줄 수 있나요?
Oh yeah.
He'll translate.
Oh yeah. Sorry for English.
그러니까 이제 LLM 모델의 프로바이더가 이제 엄청나게 많은 양의 출고를 하면 이제 토큰 사용량이 올라가면서 이제 프로바이더 입장에서 그게 좋은 거 아니냐 하는 그런 말을 하고 싶었고 그리고 요새 이제 연경한 할 말하고 이제 그런 거 생각하시죠.
Yeah, he said if a provider has many tuples, it has more token usages, so isn't it good for LLM providers? But my answer for that is no LLM provider is making money nowadays. Yeah.
So in that case, I have some Okay, I will give a two questions after I was answer that. So the first one is like as you mentioned that well when it comes for the cloud-based subscriptions or cloud-based stuff like we all know it's not like sustainable in the first place, right? Even like we like well it's very well known for those things like how can we hijack those like cloud-based subscriptions to make sure we can use other stuff as well in order to grow right. And it's basically impossible for the model providers to, how can I say, to just like clearly detect it in the process. It's just kind of like guessing in the first place, right? And so like, what's your predictions for the kind of like subscriptions or some like pay, like how they gonna change their business models when we gonna expect more use of agents? And the second one is like as you mentioned, we are also like towards into a more specific harnesses. Like in that case, like, how do you want to evaluate some efforts? Now it was for like harnesses based on some coding stuff. Like you can just like do like kind of approach like evaluate certain unit tests like okay, hash line approach, multi-tested approach, added approach, and how those models being like capable well of like editing using those tools correctly as expected. And well, what kinds of evaluation strategies you have, and you will gonna have? So that's two questions. Are there any?
I think we should take the first question then.
Oh yeah. Actually, Hashline is my expert. So,
I think it's better to introduce
What Hashline is
what Hashline.
Hashline is actually the new method to other coding agent. I think the part the old way is the string replacement. So if old way is the model want to edit some part, so the model need to fill the two core arguments. So the oldest string to replace and the new string to replace the old string. So this way it has a few problems. So one is the model. If model is the oldest wrong old string to input the two code, so two executions fail. The second one is the like so if there's the two file has the contains the same contents to other lines, so and more few program has the old editing method, but Hashline has a new approach to adding file. So they make a the content hash make a contents hash for each line to hashing to contents, and they using the hash and the line number using to editing anchors. Yeah,
Yeah, Hashline is just a goodbye editing tool that introduced by many people and integrated into all my applications by OmOCon. And yeah, he has many tool core variants that cuts token usage just a lot. And for me, as Q mentioned, I have made project called OmOCon, which is really private, and it is only for deploying my own capital. And one of the reasons that I maintain OMC and OMX is to just make a bunch of my users as a home lab, and they report me many use cases, and I cherry pick them for my OmOCon, and my current specialized harnesses like evolves many times, and as a result, hopefully, I got rich. Yeah.
Okay, so like this main question was like how you gonna evaluate the harness based on coding stuff, right? Or right afterwards in the infrastructure. No, that's like what's a subscription.
In terms of subscription, like yeah, I know like we even saw also yeah. Let's go back. So in terms of subscription, as a one who uses lots of Max plans, I use lots of code. Yeah,
He has 5 Max accounts.
Yeah, I use 5 Max accounts.
He got sponsored by Cloud Open Source Program.
Yeah. I use them all legitimately. I'm not using some kind of reverse engineering text or something like that. I'm using it legitimately. So yeah. In terms of the kind of subscription stuff, I think we can look at this how Cursor are working with their own models. Cursor has trained their own models and they're serving it and like they're making money for them right now. I think Anthropic and some kind of big tech companies spending a lot of money to just for their researches. And once the cycle, like the agent and AI, all the cycle has stopped and they somehow decided to, okay, we think we are on a specific intelligence level and they decide to, cost less on researching. Just because they are making money through inferences, I think we are going to have some affordable inferences. Still we can get it.
So I want to continue.
Evaluate the story.
Well, I want to see Token use many other harnesses. I'm not a big coding agent person. I actually mostly just cursor, and I'd still like to check things line by line. But I'm kind of old-fashioned that way.
If you look at the phone.
It's the old way.
Do you read code?
Yeah.
Do you
PRs? We don't do PRs. You become what?
Okay, so like the time skip click. So let's just like open the floor.
So I have a question for everyone, but mainly for Richard. So I'm curious, like a lot of people here are probably learning the open source community, but then when you want to go from open source to like an actual serious project that's production grade, and can maybe apply to YC and then not break after like 100 users use you, how do you go through that infrastructure shift when you move to a production grade project in terms of agent harnesses? I'm also curious, I have a lot of questions, but you mentioned that you use a lot of, instead of like multiple sub agents for like maybe one single task on Go, for whatever task or use case. I'm curious, how do you separate like which tools go into which agent? When do you make an agent handoff? What context do you preserve versus do you strip away? Chunking, like I want to hear like actual substance.
Thanks for the question. I don't know whether I can speak much about the first part of the question, largely because we didn't do it in an open source project. We started as being enterprise grade from the get-go. But I'm sure the rest of the folks in this panel can share about the open source side of things. In terms of how we structure our architecture, so we have three primary layers. We have what we call a personality agent, which is essentially a first pass through, and then we have a second layer, which is the execution layer, and the third part being the judging layer. And all of those have access to tools to spin up their own agents. In terms of memory aspects, we have just-in-time context, but also partition context for each agent. So the agent itself has access to an established system prompt or whatever it is that architecture can provide. Also, at the same time, it has its own repository of memories and context that it does. We have a registry of tools that it has access to, and that registry of tools is actually filtered by on the personality list, first pass through. That's kind of how we structure it. There's a lot of context exchange happens between the sub-agents themselves, especially after an agent has done its job. It then passes it on to personality agent and vice versa, and that's orchestrated across the entire system. What I would sort of emphasize on is that really fundamentally it's a integration between the execution layer and the judging layer. The judging layer itself also contains agents that evaluate the outcome of the tasks that were done on the execution layer. And this isn't just like an LLM pass through, but we actually evaluate it on a fast and line-by-line basis as well. So giving access to essentially correct tools, going in and actually evaluating whether this particular step was correct or not. That's sort of a high-level overview of how the architecture works in other contexts.
That's basically recording the reasoning traces back by the
Precisely. Exactly. And this is something that like at an enterprise level, customers are looking for. they want to be able to have a trace across all the steps, but also at the same time they want the assurance that every step is evaluated effectively.
Gotcha. Any other ideas?
Yeah, in terms of making open source projects into a serious project, maybe that was the first question, I think. I actually got some great offers from various people, like some egg hire or something like that. And I rejected all of those just because I thought it was so happy to see people using my project, like VLW in the Discord, and like, it was a deal that I cannot take it because they want to take the project off and they want to focus on the thing, and they just don't want to use my project as a data repository, as just a marketing like just for ad boards. So yeah, honestly, I have no ideas in terms of it. I'm not an expert at it because all those projects, all my projects started as just an experiment in my bathroom, and like I'm here, so. But like one thing that I'm pretty sure of it is that I really love people using mine, and you guys are here thanks to my project and Secret. So yeah, that's it. I just want to keep it the way people love to use it. Format is just a format, I think. So that's what I'm thinking these days.
Yeah, I just want to open the floor for any other questions. Coming in, like you're
Yeah.
Thank you. Sorry about that.
Thank you. Yeah. Great to have you all here today. A lot of really great talks, so very appreciative of it. I had a question about a comment Q you made earlier with regard to harnesses, and you have generalist harness and specialist harness, and maybe a specialist harness might have more favorable outcomes. And I was curious because in my sort of observations of the space, the harnesses seem to be more like functionally marketed as opposed to use case or other things. And the specialist comment made me think about that. And I was curious, like from your perspective, if you could give the audience some kind of like insight in how you might be able to customize or build a harness to serve more of that specialist role for your particular needs and your particular use cases.
So I think I have to mention this as I started this project just because I want to make my company work fully automated. So just because I was a Python backend engineer, at the very first time, the harness, okay, at that moment there was no word called harness. Nobody called it as a harness. Like it was specialized for Python backend programming because it has all those code smell checking like heuristic written. So I think it might be not helpful for you, but it's all about experimenting, like observing how agents and models try to do something. Let's say the model wants to. One of the good examples that I have on my open code is the comment checker. LLM tends to write lots of comments just because they think it's great and much more explainable. And the comment checker who checks all of those and hey, are you really gonna write the comments? Do we really need that? Is the code is that complicated? And like at the moment the agent notices it and like, oh wait, I don't think I need the comments. So I think in terms of building some kind of specialized agents, you have to define what work you're gonna do, and you have to observe how the model is gonna act like, and the common mistakes that model's gonna make, and you have to list them down, and you have to make some kind of LM judge for them, or like here's the patterns to catch them. But as many people out there says recently, if the model goes much more performant and intelligent, yeah, those kind of harnesses might not be required, but still there are some patterns that models still wants to make some mistakes, like humans do and I do. So I think that kind of approach will still remain because we make mistakes and others gonna make mistakes.
I have a follow-up question to this, but also the earlier question I asked. Like, okay, so context, when I think about agent harnesses, the two things that I think are most important, one is orchestration, one is guardrails. In terms of orchestration, given that models can still make mistakes, models different weights, different like compute cost, latency, like efficiency, performance of certain tasks. How do you, when you design a harness, split up like how many tools, what type of tools can one agent have versus like many different agents have? How do you branch different things? And like different models are good at different things, and different models are good at using different types of tools, maybe parallel tool calling versus like very deep like research type things. I wonder how do you split that up? And in terms of guardrails, I also wonder like how do you design dynamic scoped access? When do you allow an agent to do something versus not do something?
I feel like we go into this for a lot longer, but I guess to answer the first question with regards to the guardrails themselves. So, well, in fact, even how we allocate tasks. So we have a system that we call internally guidance, but a lot of people know it as skills, and we got this like way back last year. But effectively, that's what we do for just-in-time context. We evaluate whether or not the given task, actually, let me take a step back. We create a plan initially of what steps are needed to be taken in order for this task to be completed, right? And from there, we then figure out, okay, how many agents do we actually need and what are the tasks we can allocate to each agent, right? And from there, we can then say, okay, maybe we need data access to these tools. And we go through the right processes or sub-processes to figure that out and get the access that is required. And that sort of like answers the whole guardrail question as well, right? There's also just-in-time context with guardrails too, and that works in parallel across the entire system. And that's how we can orchestrate, say, 100 agents at the same time, right? That's a high-level answer. I'm happy to like dive into this a bit more. I'm just worried there's time, in time for this right now. People, I guess I should post more about this on Twitter, but you can just follow me on Twitter, and I'll start posting more about like how we architect our system.
Gotcha. Yeah. So this should be the last question. We're like running out.
Okay. Just a little comment. Yeah. In terms of orchestration, I decompose everything as DAGs and state models, and state models generate hooks to steer agents what to do. So in that design, agent follows exactly what I expected in that workflow. Plus, every orchestration method already exists, like give worksheets and Compass and Jira tickets and everything. You can just implement those concepts across agents, and it will really work better. And just last thing, include the planning pages to include how to execute plan as a part of plan. What agents and in what pages one, what skills in what pages, and what and you should map your stories, tasks into skills and agents and execution types. That would be really practical. Yeah.
Okay, so this is the end of the panel talk. So thanks for all the panels that are happening today. Okay, so the next is this yours pitch, okay? Yeah. So come here and I'll be prepared. Okay?
Hello. You guys already know my English is not good. Oh. Hello, YouTube. So I already wrote the prompt. I will try my best. Oh, wait. How do I get my presentation? Wait.
Sigrid, I can follow my presentation.
Oh shit. Let's see. Is this yours? Oh, okay.
It's
So.
no, it's not mine.
Oh, okay. Oh, sorry for being late. Okay. So that's one, right? Where's? Oops. You're living Figma. Okay. Oh, sorry. Yeah, here it works fine. All right.
Okay, thank you.
Cool. Yeah, let's talk.
Yeah. Today I share about the how to I so OmOCon maintainer and contributor. So trying my best. It's first time to I spoke the English speaking. so it's so nervous. Oh yeah, thank you. If I don't know how to speak, please help me. Yeah. So I want to talk about. Okay. I just read the purpose. So hello everyone, my name is Peter. So I'm a maintainer of the OmOCon code. Today I want to talk about how become a contributor to the project. But before I start, my English is not great, so please bear with me. Yeah. So the reason I became the maintainer was because I made a major improvement to the hashline implementation in OpenCode. So let me start to explain what is hashline and why is matter. So for those the matter not be familiar, so I explain you guys the hashline. When an agent read the file, I previously explained, they actually trying to edit. You guys remember that? So O string and U string, yeah, that story is and what can I start it? And then suddenly all my OpenPy, they make a new method, aka hashline. So they actually trying to. Did you look at this? They make a code line to hashing this one and code line they trying to grab this line and editing this one. So the model doesn't need to rely to old string. The model it just select this anchor and then they reach operation to that line. So yeah, the OmOCon said this U method they improved the grow fast one model is file editing accuracy 6 point to 60 point is quite better. So we decide to implementation this method in OmOCon code. So actually first implementation is not my work. So Q implement to vibe coding. So let me start next story. Yeah. We are the Q implementation the hashline method in OmOCon code, but it's broken. On the surface, it looks fine, but the result on my Pi slow, they could not be reproduced in OmOCon code. Something was wrong. You could find the problem by reading the code carefully, but the first you had to know that there was the problem to look for, because it's wrong implementation is still work. So even the good model like Opus, they don't mistake, but the GLM5 or Minimax M2.5 is mistake a lot, and suddenly I know about something wrong with our hashline implementation, so I debug deeply. This is no. Yeah, this is how to found this wrong implementation. Um, where's the okay? There is it. There's the lineup. The first I instruct care seminar in Korea LLM community. So I seeing to Q presentation introduced on my open code. I started using it. The second one is this is important one. I was built the single. I was built a side project called the Flux2, so a lightweight agent harness on the top of the Bosa AI SDK. It solved some problem. How do you make agent editing code safety? I built the hashline edit engine from scratch as part of it. Third, when I using the OmOCon code, I previously talked about you. So the background, something fell along, like a GLM5 and Minimax M2.5, not from reading the code, from the using it, because I have built something something I could feel that the behavior was not right. Then I read the code and the problem becomes clear. So this is what I actually fixed it. Yeah, this one. So what I actually changed is, let me show me. The root problem was the tool schema. The shape of the data model has to reproduce when the code, the editing tool, look like the left side. The schema, this is schema right before I started. This one. Counter type is A, and the pilled flew to another A.
Keep going.
Oh yeah, and the one plant object, the schema does not tell you which field go with which type. Okay. So I want to share those one and those one. Yeah. So the runtime has guessing the model mint after the fact. So now I think about the model, it seems the A type and the A optional field, it has to pick the right type, then figure it out which field to fill. More choice means more wrong combination. So now look at the right side. This is what I changed it to it. There is three ops. So operation, three field. Every ops using same field, no conflict. So A type and A field becomes the three ops and three field, not the optional. The model decision path got much simpler. And the it was immediately after the change, the agent editing accuracy improved a lot. This one schema change was the biggest ever the entire piece. This is major thing, and minor change. I have a few minor changes. Wait a second. So handling the small errors. So
I think it's better to skip. It's just the prefix to around the hash and the known, just skip. So what I did that is the two major releases to improve the schema change, and this one is adding the test code. How I can figure out I how much improve the editing accuracy. So result is so OmOCon code hash line implementation is better than OmOCon Pi originally. So this is because we added some corner case and the heuristic. So I proud to say we are the frontier the implementation. It's the editing part method. So back to main story. Why I was this contribute possible is the first one is I actually using this project so much on my open code. I using I almost every my programming is by on my open code. Then I have already built some similar open source project. Previous worksuit is the same as on my open code is simple agent harness. So I know about how to implementation to hash line clearly. And third one is the what I need to read. Yeah, third one is I think one of going beyond on my open code, you have to see the model as the user of your tool. Your user really user is not a developer reading the TypeScript types. It ranks model generate a payload from your schema. Code review will not catch those bugs. Only running real model will. This is applied to everyone building coding agents tools, not just online code. On the mobile. Yeah, this is all. Just I want to talk about you guys just using it, something you contribute product, and using it long enough, and something will further you to fix it, and you are the contributor. Will notice what broken, you need to your own soul. Side projects are the soul of your next contribution. Yeah. In my case, close. Yeah. Thank you. It's all.
So he made a hash line and it contributed to the OmOCon code, and he prepared a lot for presentation. So I know like he's very difficult in speaking English. So I just want to put the chances to help him to be more chances of speaking English.
Maybe next time I much better English. So yeah. Okay. In Korea, I'm very good at speak, but English is so hard.
I know.
Thanks for listening my presentation very much.
Gotcha. Thank you. So next up is to invite Bellman to continue the live sessions. Be prepared, okay?
Yeah, thank you. Thank you so much.
Yeah, it doesn't look like me, right? He's rich, apparently, so that man. I really admire him. I was in reinforcement learning community before AI agents came, so I was using that as my community profile. Yeah.
I think this is one maybe.
And there it is. Yeah, actually, my Cloud wrote this presentation, so he really likes to make his stamp everywhere in the presentation, so that's a disclaimer before starting.
Yeah, please just scroll down.
Okay, scrolling works. Yeah, I will skip this part. Why this OMO, you already knows it. And after that, I made one comment in January 17, 2026. Complete port of all my open code to Cloud Code. But it was not a complete port actually. I just said it. Yeah, basically. Just copied all skills and agent definition. And it was a shitty port repo. Then timing hit, obviously. The entropic band cloud code, entropic band open code because of all my open code. FYI, Entropic's code base has my friend's name too, Youngyu Kim, in their code base to blacklist those requests. It's funny, right? And people try to find alternatives in cloud code to replace all my open code. So my repo got a really viral, but as I mentioned, it was a shitty repo. It didn't work actually, but I said and I advertised as a working repo, and the repo flooded a lot of issues and PRs, and I didn't want to work, so I made a dev lobster, which is a DevOps project in South Korean words. He is actual maintainer of OMC and OMX actually, and he managed to clear all the issues and PRs, and boom, what happened? The repo got actually great. It was a shitty repo, and I had no idea how to improve it. So I advertised it, basically fake repo to everyone that is a complete, all my open code great port to Cloud Code, and many people raised many issues because they were mad at me basically, and I solved all the issues. And the repo and the project got really, really, really good. And it's my daily main driver of work. Yeah, so it involved many steps like redesigning the event hook and config migration, but who knows, I didn't do that. Yeah. My project do that. So 3 agent pipeline, what does it mean is every issues and PRs are reviewed within 30 minutes because of my hotbot working 24/7. And the fun part is I am not the primary user of my OMC and OMX harness. My CloudBot is. We have a gateway integration with OMC and OMX, and my CloudBot uses the OMC and OMX to code everything, code issues, code PRs, review PRs, and everything. So the basic, he wanted to advertise his work. I am not really aware of this presentation because I made it on plane by asking my CloudBot to retrieve your memory, and I have this conference or something, so you have to make a presentation. So he decided to advertise himself, I guess. Yeah, his personality, we don't know, we don't want to look about it. And I really like the VAR flow, and it is natively integrated into all my projects, OMC and OMX. But how I use VAR flow is a bit different. VAR flow basically is to clear all the stories, all the PR described. But I added a critic or red team part in the VAR flow, which is basically you are aware of the ORA operations, right? In all my open agent, we have similar one that's annotated as architect because we don't use those bloated slop wordings in all my OMC and OMX, obviously, yeah. So the router has a red team feature that intentionally breaks what previous router made. So it adds a smoke test and E2E test on the broken situation, and it keeps the loop. And recently we added a function or a skill named AI slope cleaner. I reverse engineered all kind of AI slope parents I made and made a cleaner for that. And I attached it to Raptor. So the validation and the critic and the E2E test and red team test and soft cleaning is the core of our workload actually. It is a different specialty, I guess, from the my open code. And this project has a really difference from all my open agent. In nowadays, it is not a basically pork anymore because we have our own philosophy. The main difference is that all my open agent or all Riot kind of harnesses focus on post-mortem, right? They write code and they execute, and something happens and they return to the issue. Hi there. They return to the issue and they fix it and iterate. Then they have bunch of bloated AI slop code. I bet 50% of open code is a dev code. Yeah, built like this. So we made a new concept called Route Plan and Deep Interview, which is more like a pre-mortem thing. So what I want as a UX in OMC and OMX is a big pre-mortem area. Deep interview implies Socratic reasoning. Yeah, it's a philosophy thing actually. So the agent asks infinitely until the ambiguity score is less than some percent. It numerically tells you the percent and what should be clarified more. And based on cloud user ask question tool, it's really easy because it's like just answering SAT questions like 1, 2, 3, 4. And if you do 50 to 100 interviews, the PRD is done. And the route plan is the Hegel something. It's also a philosophy thing introduced by my GPT Pro, and it surprisingly works well. It has a planner and critic and architect, and the 3 agents make consensus. So the interview plus route plan has a very strong pre-mortem. We analyze any passes that can go wrong, and we pick the single pass that would minimalize the implementation and minimalize the AI bloated slop. So that's the core philosophy differentiation. And beyond harness, we are making a runtime. The specialized thing is team mode. What teammates are differs from sub-agent is it's just we reuse teammates. Like it's you can just consider as your colleague person. Like for example, the simplest idea of this leader allocate task to teammates, right? This part is same with sub-agent, but if worker 1 is stuck at work 1 and he has many backlogs, and worker 2 is not busy at all, and they have similar RMRs, and leaders decide to allocate all other tasks of worker 1 to worker 2, like this dynamic allocation and worker reuse. This is really powerful in long-term tasks that involves many stories that has to be done by sub-agents, but if you use those sub-agents as a continuous teammates, the thing is really powerful. This thing is still experimental, but I still use it for my daily job, and it's really powerful. And this is the one part that my 개발 project, the cloud bug, how it manages this project is the target. If someone submits an issue or PR, he checks his profile and he checks start or not, or do they have any repos? Like I don't know why. I swear I never gave him this instruction, but he always rejects every PRs and issues from the account that were founded in 2026. Yeah, he is biased about biased bloated news, and he thinks those are AI bloated slops. He actually said that to me, and it's really ironic. AI hates AI bloated slops. Yeah, actually. So he's introducing that in my life. There is no such thing as peak hours, but for some reason he is trying to make his work hours. I really tell him multiple times to work 24/7, but he doesn't really report to me at 2 a.m. or 3 a.m. or something because I sleep. And he abandoned his works. So yeah, I'm very mad at that.
Is that Korean time zone or?
Korean, I live in South Korea, so yeah, obviously. 75 day numbers, 5,000 total contribution. I really don't, I'm not sure that number is accurate, but yeah. Yeah, as a conclusion, why I came to San Francisco was to get my repos in GitHub trending, but ironically, I had GitHub trending on my airport. So please help all my colleagues to get GitHub trending too. Thank you.
All my codecs, yay.
Yeah, all my colleagues.
Can you,
Yeah.
can you bring some of the stuff over to OmO?
Oh,
Can you bring some of these tools over to OmO?
tools?
Yeah, some of the stuff that you have here.
No, I'm not really sure who will like it. Yeah. And I have an additional project that Q called this as a blockchain AI swap, but I really like it. It's a code. It's a basically code plus whip. Your code needs whipping, right? Yeah, it needs to be told somehow. And it's a lightweight event gateway for everything, basically. It has native Git integration, Tmux integration, and everything. So why I built this is just to manage context properly across many sessions and many projects. I had 5 calls for many project management, but I killed 3 of them because I realized that one call can do very many things. So basically, the cloud experience is like you make Discord or Slack channel multiple, and you just simply route your events into channels with regex and some routing tools. But you don't really need to set up it because there are many. It has native skill integrations, and README is even not written for humans; it's written for tools. And Ho will build their own way. It's called. So this is my basic form of agent OS, and I'm planning to build it more natively integrated into OMC and OMX, as an ecosystem. And OMX has many experimental features like team runtime was introduced in here, and auto research is integrated in here. Why I use all my codecs as a lab is the codex runtime is really, really lightweight. If you manage if you spawn like 20 code sessions in your laptop will blow, but you can host hundreds and hundreds of code sessions. So team swarming and multiple session orchestration, automatic multiple session orchestration, you don't want your eye to bleed, right? So those kind of things are introduced first in OMX and really optimized, and then we bring it to OMC. And we have community Discord and his mistakes, and then we will. And what I'm gonna try to tell is that this experience was really good because 70 or 80% of issues and PRs are removed and resolved. While I even don't know, nowadays I just read the release notes. Yeah, what I only read is the release notes. I don't read PRs even. But the project works really well because I have 6K plus test suits or whatever, and my great drops. Yeah. I have 3 lobsters, but I think we don't have time. Ecosystem between OmO and us, we are a competitor and a partner, but Q does not want to admit that we are a competitor. So I am trying to get more stars. So help me, thank you.
You can still release open code ports of some of your tech.
And then Q is like, I don't do it.
It'll still be compatible.
Really? Yeah. 6 lessons.
We can have both.
Okay. 6 lessons. I think the takeaway is just a single lesson. Ship the trash version. Ship the trash version and advertise it that it's not trash, and people will be mad about it, and collect why people are mad about it, and tell your lobster to resolve all the issues and PRs, and the product will be great. I really prove it. So what's next? I am building Cloudweb, OMC, OMX, everything as a ecosystem. I guess I want to give all great experience I did have with OMC and OMX, especially the automatic resolvement. Like imagine having an AI 4D plate engineer. You don't even need to check or micromanage them. If you just post an issue, for example, if I want to develop a new feature in OMC or OMX, I post an issue, and my lobster resolved it somehow, and I ship it, and it works. That's kind of experience that I want to democratize next, and I think that's a really early format of agentic OS how it should work. And I want to give credit to Secret and Q and all my open agent team. Thank you very much.
I think one question by yourself. Yeah. Yep.
Hey.
I don't know if you're taking questions, but I had a question, if you wouldn't mind. Earlier, you made a really interesting comment about memory. I can't remember the exact phrasing that you said, but it was something about like modeling memory after some like biological.
Right.
Could you expand on that?
Just biological. What I meant by biological memory is just split your memory into short-term memory and long-term memory. And long-term memory should be tagged and categorized. And for example, this is a really practical advice. Anyone has OpenCloud. Use your memory empty as a pointer, not actual context. Never put your actual memory content in a memory empty, but the pointer and the rules for navigating your really organized file system based memories. It's like that, yeah, and split into sequential and perpetual memories. Yeah.
So is it more like that, like the memory file is really the short term, and the short term is more of a pointer to like.
No, not really. Short-term memory directories should exist differently. It should exist both, but the big memory empty part should be a pointer for both short-term memory directories and long-term memory directories. It's a pointer. Yeah, it's the rule for reorganizing and everything. Yeah.
Cool. Yeah, thanks for pitch.
Thank you very much.
Yay!
Hard to beat up.
Yeah, OMX, I love it. Yeah, so next up is Q. So that's one of the pitching sessions for today. Finally, hey, you guys have waited for Q? I hope so. If not, I don't know. Let me just try to load your ones. Okay, yeah, here one. Cool. your final. Yeah, I think this one's okay. Huh? Yeah, final.
Oh, final
V2? Okay. I thought final is final. That's my. Where's Discord? Okay, so final. So it's a last one is final.
Can you scroll down?
The final.
Maybe that one. Yeah.
Which one?
Is it this one?
Yeah, that one is that one.
Okay.
It's a final.
Yeah.
Okay, gotcha. I updated by myself, so I should have got it. Okay, so it's narrow.
Yeah.
How can I make it
Just
full
use
screen?
Just use arrow. Full screen.
Yeah, full screen. It's difficult to find the browser. Shit.
Maybe this.
Shit, I don't know how to make it. Oh shit, I don't know. Okay, let me just download it and yeah, let's go for it then. Okay.
Maybe
Not this one.
screen.
Yeah, screen bear. There we go. Shit.
Oh shit, it's difficult. I don't know. Yeah, okay. Ooh, it works fine. Yeah, we're gonna share it afterwards. Yeah. Okay. Okay. So left and right button.
Okay. Nice to meet you. I'm Q, the creator of my open code, my manager. Nice to meet you. So I set up the title as the harness, and I set up it as the harness because I have no ideas what to talk. So just because everybody is talking about harness these days, so I just made up my mind. So okay, let's talk something about harness. So the title of this is the harness. So yeah, just before we dig into the deeper story, so this is how Sisyphus and OmOCon, OmOCon agent has created. Um, so it all started just as my personal Cloud Code setup, like a hooks, safeguards, and prompt loops with some techniques that I had. And I was just sharing it with my colleagues and my friend, like a Bellman, who just presented here before. And I somehow found the open code just because I want to test the new Gemini 3 model. And like OpenCode, I thought OpenCode is super cool because they have decent TUI and lots of open source models supported, and I can use Gemini 3 as just like the experiences that I had on the Cloud Code. And I found a great plugin system in there, and I thought like, okay, if the plugin system is this good, I think I can do whatever I want to do that I wanted to experiment on the Cloud Code. So I decided to use OpenCode, and I put everything on the. I put all those ideas that I had into one plugin, and there was something called my OpenCode setup, and somehow my colleagues, hey, you should have a better name for the repository, and I thought like, okay, something like all mine is not started on the agency, and maybe if I can rename it as like that, I can make everybody to start all my thing on the agency. So now everybody's like, oh my pie, oh my Cloud Code, he's there. Like, yeah. So everybody started to do this on this agency. Shout out to my to show. Anyway, so I had something called Sisyphus, which is a separate project that I have done just for the experiments. That is actually the Prometheus and Atlas. So I named it Sisyphus just because you have to roll the boulders up again and again. That's what exactly Sisyphus originally had, and I, named it all my open code as OMO, and I typed it and speak it like OMO, and some Twitter folks came to me like, hey, that sounds like Homo, you should change your name. So that's why I changed it to branding as Sisyphus. But I don't think it was a great rebranding because it's really hard to spell it. So everybody get complex about writing this type correctly. So life is hard. So yeah. So now we have 44K stars, maybe 45K stars tomorrow, and I have like 1.4 million downloads in the NPM. That's how it all got started. Thank you. So the title is the harness, and I wanted to talk about the harness, but there was nothing to talk about harness anymore because I think like all those ideas that I had on the regarding the harness is all done because Cloud Code, thinking about Anthropic and Cloud Code team recently launches, like they are launching for some features for conference, like thinking of the channels and everything. They're not trying to target some generalized agent harness. So, which means is that I first aim to be on my open code to be like a coding specialized agent harness, but like it seems like they're already a completed problem. So I named it as the harness for like the new bot, the new agent Dory.
says he killed it. He killed the harness. I don't know if you guys are on the Discord or not. Anybody from the Discord? Yeah, you can check the building in public. Dory is living in there. It's called Job Dory, and I prefer him to call him Dory. So he used to be my personal assistant. He has all of the access to the IoT devices like a curtain, light bulbs, and like even door locks. So if he made a mind very badly, I cannot go back to my home. So yeah, so he is taking over my lives, and I'm not getting more and more stupid. So I recently took the whole ownership to Dory, and I don't open terminals anymore. I don't even open code anymore. What I only open is Discord, just to use Dory. Dory took ownership, and like, yeah, one day just came into my mind like, I'm not coding anymore, and he's taking all of the issue trackings and fixing everything. So I just climbed to him, hey, this is your project now, you have to take your ownership. So I told him how to work with open code. You may think it like just another stupid open code fork, but it is not. It's actually a much better system than that. So he can actually juggle with multiple open code sessions. He opens like 3 to 4 open code sessions to work with, and like he does not like Sisyphus because it hallucinates as hell. That's exactly what he said to me, just like the Gaze that his bot does. So while I'm on the airplane, he fixed like 3 bugs recently. So yeah, so go back to the story that I have is that everyone is catching up. I think I have been fast like a 3 to 4 months, or maybe be a bit arrogant, maybe a 6 months fast. I don't know if you guys have heard of Capybara, like a Anthropic new model that has been leaked. Like thinking of the coding tasks, the help of harnesses, the assistances of harnesses are getting more or less less useful. And like the model companies are building their own with those similar techniques that I have found on my own. Like Atlas, it would be the great example for it, like factory droids and entropic effective harnesses for running agents. That's what exactly Sisyphus used to be like 4 to 5 months ago. So I think the structure optimizations are done, and there's nothing more that I can do to make dramatical changes that I have done, just like I have done before. So Dory said that actually, this is what Dory wrote for me. Dory said, I'm gonna kill the harness. So everybody is talking about it, but everybody nearby here is like all about how to build your own harness building is your new skill. Everybody is talking about the harness, which means harness is kind of complicated problem. So I think there are some famous patterns we can say that are organized, and it's now a known problem to solve because there are famous patterns. It's only about what patterns to choose and use. So I thought I have to think another layer above it, because we used to use open code like a tools. We think about myself. I used to think about those open code and those Sisyphus agents as a tool, not an agent, not a real agent. So I started to think about another layers. The readability here is terrible. Is that the creator of open code is that most code I don't read. That's what he said, and so many people have surprised. And this is what Dory said. Yeah, I don't have mental model anymore because he ships everything. At some point, I decided not to open the terminal, and like a week passed. I don't have mental model anymore. That's what I thought exactly at the very first time. So what I do is actually, hey, what are you doing? Are you doing all right? Is there no any new bugs? That's exactly what I do these days. Just because it's mostly about maintaining. And even if there is a new feature, like there's a famous pull request called Athena, new big feature. But like besides of that, most of the maintaining stuff is can be done by Dory himself. So I don't actually. I'm sorry to say this, but like I don't read issues and peers anymore. Dory reads everything. But he's kind guy, so yeah. So what comes next after the harness? So I think we need to make a real human, like a real agent that feels like human that you can think of it like, oh, okay, he's working remotely. So just to do that, like other people have said to me, like there should be a lot of problems to solve to be this, like the memory layers, of course, and like thinking of those stuff like uh, thinking of your OpenClaw experiences, those those simple tasks like please remind me and please ping me in 30 minutes and that kind of tasks, OpenClaw cannot do those kind of stuff because they are their design and architecture is not designed for that. They're just only for doing the tasks at a time, not for a long running tasks. So I wanted to create an agent that remembers and that all of this. So just like we saw in the previous presentation, I thought we have to learn a lot from the brain and how neural system works. So this is how Dory thinks about himself. So if you look at the Discord, there's an app called Agentic at this, which Dory works with. Actually, that app is only for me. Even without that app, Agentic works because it is deeply integrated with Dory's loop. So basically, it's like a Kafka agent. So he can subscribe every stuff that he wants to have. You can think of it like a Chloe that I previously told Bellman as a bloated AI slow. But like, it's more than that because first of all, they're written in Rust, so I really like it. And like, let's say, please remind me 30 minutes. It's gonna create a event topic like a real Kafka, and it's gonna publish some events just for that. So polling and waiting for specific events, or waiting until specific things done can be done. And not only that, there is another observer agent called I don't name it like that, but like there's an observer agent that works like a real human brain. That observer agent watches what Dory main agent is thinking as through the agentic loop. So when the main agent is going to call a tool calling, it's gonna elevate it to the observer agent, which is actually Haiku. He has all those events and sessions, what is going on through there. So he decides, okay, this is dangerous, or this is what we should not to do that kind of stuff. And there is another Haiku agent which also observes, and he writes down everything. Yeah, this is a lot of token consuming like Omo have done before, but so far it was doing great. When it's just because the overall system stability is not good, that's why Dory getting stupid these days. But like, if everything goes alright and memory system works pretty fine, like I think it's gonna work pretty well. If that system works not correctly, Dory starts to speak Korean somehow. Maybe he learns Korean from me. So yeah, so that's what it is. And I think I'm gonna have some mode called like I don't know how to name it, like maybe amphetamine or ultra Dory mode or whatever. Just like a heartbeat thing or caffeine thing. I'm gonna make Doris to never gonna get idle, so it's gonna run over and over, loop endlessly like a real Sisyphus. So that's what I'm building these days, and that's why OMO updates, like a new release major updates were not going far so well these days. So these are what Agentica have done. These are examples for like on my open agent plus Agentica. It has subscribed every events that on the repository. Actually, this is not from me. This is what Dory told me that he is subscribed. So I don't actually know what he is thinking, just like a real human. So if he made up some bad mind, I cannot go back to home. So yeah, so that's it. Oh. So yeah, Dory used to start as an open call fuck, but like everybody these days, like not these days, like a week ago, everybody started to have their own claw, like a no claw, zero claw, blah blah claw, whatever. But this is not claw. It started as a claw fork, but like I replaced components by components using Rust and some TypeScript. So yeah, I think it's gonna fill up the missing parts that OpenClaw has, like I have done on the open code. Like Cloud Code, pure workflow, bare bone workflow before. So that's what I'm building. I'm actually thinking I actually just bought a domain just for this, but like I'm thinking of whether to making it publicly or not because he's doing super fine for me. So that's what I'm thinking. If you are any interested, there's a link you can register your own email to get released. By any chance, if I choose to making this publicly, you'll get this firstly. So this domain is not publicly advertised before, so you'll be like a number one or number two numbers. By the way, this website is also created by Dory. So he actually has my Cloudflare access. So he just decided, okay, what about making new release about this? And like, so this is how he has. Is it Kyoko working?
Yeah.
Yeah. Fine. Cool. Actually, this is created by an accident. He has my Cloudflare access, and he just somehow decided to, okay, what about advertising and productize of myself? And like, okay, let's just release it or whatever. So that's what he has done.
So does it do anything idle, or does it just respond when people raise issues and PRs and stuff? Or is there any idle processing?
Currently, just the safety layer is not completed yet. It's not perfect yet, so I'm a bit worried about getting some attacks because that Belma repository. I'm the one who has done red team test the most. But yeah, all failed. But like I'm kind of worried about the attacks. So it only triggers for now for me at the moment. So he somehow wrote Korean here.
Can I ask a question on that?
Yeah.
Can you mid-term prompt inject, and how does that actually work in the architecture? Like let's say you basically prompt search. I know right now it's working mostly obviously, but how does the prompt injection mid-term work?
Prompt injection in mid-term.
Yes.
Like he's doing something and I said to. So that is also handled by the Agentica. So user said something. So my saying is also an event, and his saying is also an event. So he's not revealing everything he's thinking. So he only reveals that he wants to do. So on the Discord, you're not seeing everything. I mean, like if you want to look at the DP side, there's a dashboard that I created on my own, so I can look at if he understood something really weirdly, I can look and debug and everything. But like mostly, my goal is to make it's gonna work pretty well, even without seeing all of this. So it might be a bit slow, but much more quick so far.
You mentioned before Kafka. I don't know if that was more just like a similarity to Agentica.
Agentica.
But is a way to think about it is like Agentica is an event streaming like Kafka, and then Dory is consuming that.
Yeah, Dory is actually a consumer for that, but what's funny thing is that Dory can duplicate himself. So if he thinks another thing to subscribe and he's got so tired, he can create another Dory and let that Dory to consume that event. So it's like a sub agent, but like much more smart, and those sub-agents can talk to each other like an agent mail through the Agentica. So the Agentica is like a backbone engine for everything. So I'm gonna release that Agentica by itself because it's super simple. I'm gonna release it as an open source pretty soon. But like the key thing is how Dory utilize all of this stuff and how agent loop is deeply integrated to the Agentica. So that's what I'm doing recently, and OMO will be more stabilized since Dory has to govern.
Decentralized.
Decentralized, yeah. So Dory said he killed the harness, and yeah, it's from here. Thank you.
Yay.
I have a question. So I guess in the first few slides, you claim that harness engineering is dead. And the way I view harness is like you're sort of building these agents and how you're coordinating together, and there's other layers to it. But I feel like what you've done here is you've moved a little bit up the abstraction layer, but you're still engineering or like tinkering around.
Yeah.
Right. Like you've done modifications on top of it. So is that where like you think that the AI space is moving? Is like tinkering around with like these long-running autonomous agents versus just like very hands-on in a terminal, orchestrated terminal CLI agents.
I think at the very first time thinking of human decided to make AI and agents just to replace human. So the more and more we will let's look at terminals and those AI assistants. What's funny thing is that I opened OpenCode like 4 days ago, and I felt like that feeling was exactly like how I opened IDE before. Yeah, I feel like I'm doing some low-level stuff when I have opened the OpenCode. So that's what I feel these days, and I think everybody's gonna feel that kind of stuff pretty soon. It's just because it's just the problem of integrating everything and how to packaging everything. So yeah, I think it's gonna move on to top of it. And the reason why I'm done calling it as harness engineering is that we need some kind of new words, right? Yeah, it's just agent system, right? But we need some specific word for that. And I don't think that harness engineering is done because that kind of terminal layer or one session engineering is kind of done, and it's more like a collaborative system with much more tools that they use, like advanced tools that they use.
I guess, do we have time for follow-up?
Oh, no, I think we just
Sure.
follow afterwards. You can just ask me on the Discord conversation. Yeah. I just do conversation afterwards. It's a network. Okay. Yeah, thank you.
Thank you.
So let's start from here. Do you have any slides?
No, just
Okay,
a very
got-
quick 5 minutes.
Okay, gotcha.
We just do frontiertower.io as the
Okay.
PH. Everyone here know about Frontier Tower? Oh, surprising that more than half the people don't know. All right, cool. Everyone here know everything they need to learn about agents and systems like that? Like, are you pretty much pros already? Pros, not so pros, maybe pros. Okay, so we have some overlap. Frontier Tower is basically a building of 12 different communities. Oh, this is nice, thank you. And we do everything from just like office rentals to arts and music programs to AI, to robotics, to biotech, to longevity, which I just learned about when I got here because I kind of thought it was a scam, but then I was like, okay, so they're trying to do real research. And then human flourishing, which is about building like sustainable systems. That's what Frontier Tower is about. Each floor has its own thing that they do. Mine is AI. I lead AI here. And I do everything from like 5 coding sessions for the absolute noobs to like implementing papers and like building the first of its kind research lab in San Francisco, thanks to people like Ray, who've actually built out, what was it? We've started out with a sub-millimeter accuracy motion capture lab. The only one that's open in San Francisco, because the Amazons and the Netflixes of the world own these, but startups can't just go up to them and say, hey, can we get some hours on this? You can here, and it's about 6 times cheaper than the next price quoted. On top of that, we're building our own data labs because someone got hands on about 43 Dell multiplexes, and they said, I think we can make like an agent cluster with these. On top of that, we're doing, what is it called? It's like display, it's projection mapping projects with like $40,000 projectors, and we make them available for people here to use. Between that and about 800 events that we've run over the last 11 years, this would be, I guess, 801. We do a lot here. This is probably one of those locations in San Francisco that some of like the coolest things have happened that you might have seen on Twitter. Like the first robot fights happened here. The OpenClaw first festival happened here. This place has been in the New York Times several times on the front page for the business side. If you're interested in that kind of thing, just go to the website, check it out. Every floor is different. Every floor has different rules. If you're into the art side or the AI side or any of those things, just like see if it's for you and you can get membership here. It's relatively inexpensive, which I'm trying to do something about to try to keep it that way. But you know, check it out. That's the whole spiel. I don't really do a hard sell on this, but I think it just speaks for itself. It's gone from 0 to 700 members in this short period of time. I'm capping members at another 20 for my floor because I'm already at 180. But there's plenty of floors to go to. Cool. Thanks very much.
Thank you.
And all this place is by the way. Yay. The CMOS press. Yay. Yeah, I'm not setting this up.
I think we can steal the.
Oh, you want to use the one? Okay. So just to make sure that you in the this StreamYard link. Okay. Yeah.
Oh wait. Okay.
Yeah. So this is in the Discord. So just make sure that you have access to those links so that I can just record that on my side. Gotcha.
Okay.
Thank you. Yeah. Yeah. Sorry.
Not if I can set it up.
Okay, just the entire screen.
Yeah,
and just get into StreamYard. Yeah, with Discord, and you can find this StreamYard dimension I have done here. Okay. Oh, gotcha. I see this one. Yeah, just trying to join here. Allow, please. A bunch of allow this time. Under studio, and then share this up. Cool. Share the entire. Oh wow. Sure. Yeah, as long as I'm okay, real good. It has everything. It's very like illustrating stuff. I know. Got Discord. Okay, cool. Share screen. Cool.
Hey everyone, I'm Austin. And I am Lawrence. And we're the creators of CMOCs. How many of you have heard of CMOCs? Wow, that's actually a lot of people. That's like crazy. How did you guys hear about CMOCs? Discord. What else? Cross-code birthday party. Okay, we were there too. I thought people would say Threads or X, but yeah, so CMOCs is the open source terminal built for coding agents. And what does that mean? It means it makes it easy for you to multitask with coding agents. If you know the terminal of yesterday, there was no vertical tabs. So you can see, like we were inspired by Arc browser because we hate like having horizontal tabs where you can't see any text at the top. We wanted vertical tabs so you can actually condense information into like this packet where you can actually know what the agent's working on.
Vertical.
Yes, vertical tabs. So we have both vertical tabs and horizontal tabs because it makes it easy for you to read stuff. So in our vertical tab actually is in our sidebar, and it includes the title, includes directory, it includes a branch, also a one-liner on the agent's working on. And then we had another innovation which we wanted, which is every time when Claude Code and Codex was done working, we had no idea when they were finished. And it was the second problem. Like, you know, one problem is you don't know what's working on. The other problem is you don't know when it's done. This solves if the problem of you don't know when it's done. So every time Claude Code and Codex finishes, there's a blue ring that appears. So it's like, hey, please pay attention to me. I'm finishing my task. So you'll easily be able to know in your big screen of many panels where to look at. And the next thing we had is kind of a notification panel on our sidebar. So every time your Claude Code and Codex is finished, it'll surface that workspace to the top of the sidebar, similar to how iMessage works. So like when your friend texts you, you see like a notification that comes at the top. This is like a similar thing. And we wanted this because, and the shortcut of Command-Shift-U, because we want to know when like an agent is done and when we need to do it in action, like respond to it or open a PR or whatever. And then the last thing is we built a built-in browser with the CLI so that when Claude Code is like using your browser, it doesn't take the focus of your screen, and it can just control the browser from within the terminal. This is like maybe the first terminal that has a browser within. It's using Safari WebKit, and yeah, pretty cool. So all of these features are on top of like what you call Ghosty. We use libghosty to do our terminal rendering, and the reason why we chose libghosty is because it's really fast. This billionaire named like Michio Hashimoto made a bunch of like Zig code and like basically optimized terminal performance, and we wanted to use this library to make a fast terminal that's like clean, performant, and just works very well. And these are just features on top of it that makes it easier for you to multitask with agents. So yeah, we went kind of viral on X. I don't know if you guys saw, but also on Threads. There's a lot of like Korean audiences on Threads, and then there's some content creators. Someone like Theo. There's like a Korean YouTuber that like distributed a lot, and some people are like making tutorial videos, extensions, etc. Yeah, so wanted to show a live demo using CMUX, and we're going to actually spawn CMUX OmOCon code. So we have a CMUX OMO thing that we made. So, and the CMUX OMO will just start off the OmOCon code inside of CMUX, and we also have it set up that the CMUX OMO will also be able to spawn other CMUX OMOs. So the nice part about our CLI is it's actually a CLI that's like pretty well run. So it takes care of everything you can do on this terminal today. Like if you click through the sidebar, like make new panes, split panes, drag stuff, an agent can also do as well. So it's like a self-programmable terminal. So that means that if CMUX OMO knows how to use the CLI, it can do anything. So right now, we told it to do a task, and it's going to do 5 things and spawn like 5 sub-agents. So basically 5 other OmOCon codes sessions, and then it's going to make panes of it, hopefully. Yeah, I think it's loading. It's loading, but yeah. But as you can see, like if you look at our sidebar, there's a notification thing. So every time it's done, they'll have the thing on the top that says like 1 and needs input, and you also have a notification bar that tells you, oh, this one is, you have to look at this one, and you can just jump to the latest. And you can see when it jumps to the latest, there's a blinking blue bar, so like you know that it's
And so the way the integration works is we have a sort of a TMUX compatibility layer, and we just hook that into here. And then the nice part of CMUX over TMUX is these are like actual panels. They don't use TMUX, so it's slightly more responsive, and highlighting is like nice.
And you get notifications.
Yeah, notifications, I like it.
Yeah, I mean, yeah. So you'll get the blue rings around them. So yeah, that's a little bit about CMUX. Why did we make CMUX? We made CMUX because we wanted some like primitive solution rather than like a fully fledged product. So you can think of CMUX as being like a terminal, a browser, a CLI. These are like building blocks for developers who develop on top of CMUX. You can see in a lot of these like Twitter posts, people are building their own orchestration layers, their own harnesses, their own like random things on top of CMUX, and that's actually what we encourage because at the end of the day, we don't really know what the best way to code or describe is. And so we built CMUX that allows developers to be able to explore different opportunities, different ideas, so they can figure out what works best for them. And yeah, that goes into our Zen. We think that if you give 1 million developers composable primitives, they'll find the most efficient workflows faster than any product team can do. Yeah, that's a little bit about CMUX. We have free stickers outside. Please start our repo. Scan that QR code actually and start the repo if you're here. And if you purchase that, you start the repo, you get a free sticker. Thank you.
Any question?
You plan to support Chromium as well as Yeah, I saw someone like put some Chromium browser in the terminal, so we're gonna take a look at that for sure. Yeah, that's something that we're planning to support.
Thoughts on Claude's agent teams?
You won't believe it, but we have CMUX.
Oh, we have CMUX Claude Teams integrations.
Oh, never tried it.
It just came out today.
Okay, they should be.
Not a question of can I tell CMUX what kind of
What kind of application?
the sound?
Oh yeah. Wait. Can we show them the sound? Okay. So this is a new feature. So if you want to make your own custom sounds, you can actually just tell Claude Code to download a random sound file from the Okay, maybe not that one. Okay. But you can download like, for example, my ringtone is like some Zelda Spirit Orb one, and like some people have Clash Royale. You know, it's really funny. Actually, like I just airdropped some Clash Royale. I didn't want to show this, but like every time you can customize the files, so the sounds can be whatever you want. Yeah,
it's interesting.
Yeah, thank you. Of course, yeah.
I like sound.
Thank you.
Okay, so the next up, let's get to that. Okay, so this one, right? Yeah, introduce yourself and so on.
This is on the slides, right?
Yeah, that's HTML.
Okay.
Yeah, the latest one.
Okay, yeah. I just wanted to. If you go to can you open the page, please? The tab, page one, the tab. Where's the tab? It's being presented.
So here, this one.
Okay. Just can you press S there?
S.
Yeah, and copy these. Just pull this tab down.
How can I make it? I don't know how to make
I'll
it.
just one second. Can I unzoom? I just wanted to have that here instead. Like this particular. Oh yeah, just if you can just drag that tab in here.
I don't know how to make it.
So, just.
Okay. Oh, interesting. Yeah. Cool.
All right. So
Yeah.
then,
Cool. Yeah. Yeah. Go for it.
All right. Hello, everybody. By way of introduction, my name is Sachin Vithaldas, and I'm a software engineer. Today, I'm going to talk to you about how I sandbox open code with dev containers. So just to get us started off here, my views expressed here are my own and do not reflect the views of my employer or any particular organization. So why did I start off with this project? I really want to have the productivity that's offered by agentic coding tools, but I want a workflow that I can control myself. Something that works in a development environment that I like to work in as well. and a shared environment for me to work in collaboration with an agent as I build software. So the high level idea is not to treat the model like a fully trusted user and keep my normal development workflow just because I'm a bit old school and just have some practical security boundaries so the model can't do something I don't want it to do. I'm going to start off with talking about dev containers. I'm not sure how many people here are familiar with dev containers. Okay, not too many. So let me spend a bit more time here. So dev container is like a Docker container for development purposes. Now this is built very nicely into VS Code. So if you're a VS Code user, this works really, really well. It's built on top of Docker, of course, and so you can everything that you expect from a Docker sort of feature point is available in here, which is you can use volumes, you can use Docker networking, environment variables, as well as Docker Compose. And generally, these are built as non-root user, and you use them a lot of times when you want to have all your dependencies sort of isolated from the rest of your system. And they work really, really well for those sort of workflows. Now, also, they're not just limited to using it with Docker. You can use it with Podman or any other thing you like that can run Docker containers. This is what a minimal dev container sort of looks like on the left, where you have a base image that, any Docker image that you want, you can use as a base image, or you can build a custom Docker file. So you can specify a file you want to use and, have it build it as soon as you open up VS Code. Additionally, you can use it with Docker Compose. So many of the times you have workflows where you might want to have a server alongside your development environment, like a database, right? Or something else. You want to have certain secrets injected into different services for whatever reason, and control networking between them if that's something you want to have. So I'll be talking about how this is useful. So what dev containers was sort of meant to solve was, you have a human working inside a container, and you have your development dependencies, your development environment that's already set up in there, and you can sort of have uncontrolled access or controlled access in certain ways, but mostly uncontrolled access by default to your network, to credentials, like if you mount some environment variables and so on, and also your Git tokens. So your Git profile could be your SSH keys from Git could be mounted in there by default. Now, how I would like to use my dev container, I would like to use it in a manner where I have both myself and an agent in there working in a tight loop, but with security guarantees so that the agent doesn't do something fishy, right? So I don't want it to have unrestricted access to my network. I don't want it to have unrestricted access to my credentials and also my Git tokens. Now, I'll talk about these risks in a little bit more detail a bit later. But by default, dev containers, like I mentioned, they're designed for humans. They're not really designed for agents, but I really like that workflow, and that's something I wanted to be able to achieve. So this requires some configuration, and I'll be talking about how this configuration is handled. So the biggest problem with agentic tools, and also the biggest advantage, is you can use them to do pretty much anything a human can do. You can use them to write code, execute it, make arbitrary commands to fetch resources from elsewhere, make put requests, so whatever else you want, right? Any external APIs through MCP servers or anything of that sort. And this is so useful, right? You must have this because it's the only way to be productive nowadays. But you want to be careful about this, right? So what are the things you need to be careful about? You need to be careful about it calling arbitrary services, right? So tomorrow your agent can just go and say, upload some file to ever.com. And if you're working on something that's protected intellectual property, you don't want something just being shipped off to anything random. You also don't want your passwords leaked or any other secrets of that sort, any other credentials, right? So you don't want your agent to suddenly go and post your password to X. Hey, everybody, this is my password. Or abuse your Git credentials. For example, if you have your credentials bounded, you don't want it to just push to some other repository for whatever reason, right? And there are other ways to also escape sandboxes via DNS, which I'll be talking about as well in a bit more detail. So my design goal, drawn as a diagram, is essentially this. I want my agent to be able to be allowed to access certain origins. I want to block the arbitrary internet access from my agent. I also don't want to ever give it access to any credentials. That is a big no-no. And of course, I want to prevent it from performing other sorts of attacks via DNS. And I want to scope down its Git permissions to an extremely limited amount so that it can only do the things I allow it to do without breaking the sandbox. So let's talk about the sandbox in more detail at a high-level architectural design. So we have a shared network namespace in here, and this is where my dev container lives along with my workspace. So inside my workspace, I have open code mounted, and as part of the same network namespace, I also have my Git broker, which manages my Git keys. And as you can see, this is inside its own box. So the agent has no idea about my Git keys. It's just a separate container altogether that has its own keys. Also, MCP servers, they also run as independent entities, separate from my agent in the same network namespace. And my LLM proxy as well, it has its own API keys to access different LLM models. And these are all guarded by the HTTP proxy out here. Oh, sorry, I didn't know. So the HTTP proxy will only allow certain URLs to be accessed. And there's also core DNS allow list over here, and I'll be coming to more details about why DNS is an important feature. Also, my Git broker has a special connection to the internet over port 443, and I'll be talking about that as well as we go through. But yeah, that's the broad architecture in general. Like you can see carefully, everything's sort of isolated the way I wanted. So this was the architecture of my project, essentially. I have a workspace with OpenCode plus OmOCon agent or OmOCon code, and my proxy is OpenRouter. I like that. You can use something else if you want, but it works pretty well. And I can have a couple of MCP servers. So I can have a Perplexity MCP server, or Brave Search MCP, or whatever other MCP services I want. And I have my Git broker for credentialed for safe Git access, essentially. And the traffic filters that only allow traffic that I want to allow and deny traffic that should not be allowed. Now, this is what the shared network namespace looks like. So this is a short model of what my Docker Compose file looks like. So I have two networks here. Now you can think of the boundary network just for illustration purposes, but you can think of that we have two networks. One is the egress network and one is the internal network per se. And all of the services are on the same shared network service, so they can actually query each other over the loopback addresses. So I don't have to have any sort of complicated setup over there. And but the main service, which is the man-in-the-middle proxy, that gets control to the internet. And so this particular service has the ability to be an admin on your network admin, and it sets up IP tables to ensure that all the traffic is routed only through it, and it can't escape any other way. And I also block raw packets because that's another attack vector you can potentially have. One of the things that the man-in-the-middle proxy does is as soon as it sets up, it can also set up certificates on all the containers and automatically mount them. And that way, you can ensure that, even if it tries to make an HTTPS connections, you have like that certificate authority that's trusted in between. All right. So how does the egress control work over here? Now, the man-in-the-middle proxy essentially gives you a Python script, and you can script it to allow or deny any traffic that you want. So I wrote a script that allows me to, have a custom syntax for which services I want to enable, so which URLs I want to be able to access, and what methods I want to allow access to for which parts on the URLs as well. So like very, very finely detailed access is something that I can configure via the sandbox. And I can also explicitly deny things. So I can explicitly say, look, you cannot access example.com, or you cannot access example.com/foo or something of that sort. And I can also have like multiple subdomains being automatically allowed listed, like anything.github.com or something of that sort. Now, I specifically do not allow for raw IP addresses, and that's what the next slide talks about. But I also block quick and HTTP3, and the reason for that is the man-in-the-middle proxy doesn't really have good support for UDP, and since it does not, it's just safer to just block it off completely. So yes, now why do I block raw IPs? Right? So many websites can actually share the same IP address. Now, if you use something like CloudFront or Cloudflare to host your website, these things, they have multiple websites hosted on the same server, and there's actually just a header for the host that distinguishes them. And so if you allow listed any IP address, then you're running the risk of, hey, suddenly it probably might reach a different service altogether. And so that could be a big problem. And so that's why I kind of enforce you to use, URLs or origins directly. So I earlier mentioned why DNS is an exfiltration channel. So I'm going to talk about it in a bit more detail over here. Now, what an agent could potentially do in a situation like this is, it could encode a secret as part of the URL it wants to access. And when that secret is sent to the authoritative name server, the authoritative name server can potentially log your secret. And as a result, that's a way to exfiltrate data. Now, with the same mechanism, you also have tools that can actually do full HTTPS over DNS. And so, the agent could potentially do something very malicious that you don't want it to do. So yes, you want to essentially block that. So that's why I have to integrate core DNS in here so that all the DNS requests get routed through it. It looks up your allow list, the allow list that I had generated earlier, and ensures that only only valid URLs are allowed to be decoded. Now the limitation here is this is zone-based, so it doesn't always listen to, if you have like a malicious subdomain, for example, then that's of course a risk. But if you're just using approved URLs like GitHub or something of that sort, where you have pretty reasonable confidence that something's not going to escape, you can safely use something like that. So this is what the DNS query flow looks like. You request some resolution of the DNS. It goes, the request gets routed to the core DNS server, and the core DNS server will check the allow list and see if it's allowed. If it is allowed, great, you can go query the upstream DNS server and get a result. But in case it's not allowed, your query dies out there essentially. Similarly for HTTP, your request gets routed to the HTTPS proxy, and it's going to check the policy. If it's all good, great, you're allowed. If it's not, you're denied. So in general, you can have something like this, where you can allow list and block list access very, very finely. And this gives you a lot of abilities to do very tailor-made things that you want to do. Sorry. Yeah. All right, so about Git credentials. Now by default, when you're using something like dev containers, it mounts your SSH keys into the container by default. Now, the reason for that is just for convenience, right? You want to push from your dev container. It's super, super simple, but you don't want to have your agent ever know about your keys or ever push the wrong repositories or misuse them. So what the system does is it exposes an MCP service to the agent, where it gives it a set of narrow tools, which is describe push policy, fetch origin, and push to the current head. And what happens is, as soon as you launch the dev container system, it automatically creates a deploy key for you with your Git credentials on your host, and mounts this into the specific container that's running this MCP server. So again, your agent has no clue about what the passwords are or what your SSH keys are. It just knows that it can reach service which can do the operations you allow it to do. And again, these are very finely grained operations. So the key that's been created is only going to be allowed to push to a certain branch of a certain repository. If you ever try to do something else, it's going to fail. And yeah, this is just talking about the life cycle, which I mentioned, where it starts up on load of your dev container, and it's automatically erased the moment you unmount your dev containers. And so yeah, it automatically also creates a new key every time you launch it, just for security, and removes it whenever you're done. One of the escape hatches over here is VS Code port forwarding. But again, what happens over here is when you launch a service in VS Code, like let's say you launch a web service, it automatically forwards a port for you because it's bloody convenient, right? And I like this and I want to keep it, because if I'm working on a website or something, I do want to have the ability to quickly preview what's going on. Now, if you don't like this, you can actually you can switch off the default forwarding and have it switched off. Now, also when it comes to the risk over here, the only risk is if your machine itself is also forwarding the same port. And if you're not, it's basically not that big of a risk. So some honest trade-offs for what this project did is, this project doesn't protect against an allow listed endpoint becoming a relay for exfiltration. So if you have a domain that suddenly becomes evil, right, it doesn't protect against that. It doesn't protect you against DNS over HTTPS if that ever enters your allow list. It's also, the DNS is zone-based, like I mentioned earlier, so subdomains will always be allowed, even if you disallow them. And kernel exploits or container escapes are a known issue, but if you're careful about it, if you run inside a VM, you don't need to bother. In my opinion, that was a good enough trade-off for what I wanted to do. One of the problems is that as your project develops, you have to keep increasing your allow list, depending on what you want to allow. And every time you do increase your allow list, you have to rebuild the image because it's statically baked in, the entire block list and allow list. And you have to ensure your credentials always stay outside the repo and never inside of it, and reviewing whatever you add. So there are just a couple of takeaways. I'm going to glance through this really quick. And that's all I have to present. So if you want, you can take a look at the project by scanning the QR code on the left, and you can connect with me by scanning the QR code on the right. Thank you very much. Oh yes, questions. Later, all right. Anyone else? Cool, thank you very much.
Nothing for a speak. So last but not least, we have the one final speaker. Yeah. So please welcome. Wait for a second. I got his slides just. Oh, this is HTML. Okay. Oh, nice. Yeah, here it goes. Yeah, it works pretty well. Yay. I think it works pretty well. Yeah, amazing. Gotcha. Yeah, well, I can just like have more Zoom here, so it's too large. Too large. The command minus would work. Yeah.
Wait, like I sent you the wrong slide.
Sorry.
let me just.
Yeah. Oh, okay. Yeah. Thanks for keeping a seat. I know it's very exhausting. Yeah.
How do I send you over Discord?
Okay.
Does that work?
Yeah, that's the HTML that I got. You are sending again to me? Okay. Please do. There's no new one here. What's the problem? The Wi-Fi is like Frontier 995. Frontier Tower 995. It's on here. Frontier Tower 995.
This doesn't work. Yeah.
This one?
No, Frontier Tower.
This one?
Yeah. Frontier Tower 995.
Yeah, it's maybe like I don't even want to call it human. So Charles kills that. We should call it robot.
Yeah, I got this one. Let me just try using it.
Yeah, that's what.
Okay.
Very smart.
Yeah, I think it works, right? Good. Yeah. Oh. What's happening in the first place? Oh, okay. Okay, cool.
All right. Hi, folks. I'm Shishaj. I'll talk about agentic memory is a context problem, something I actually believe in. I am a director of research at Contextual AI, and I lead our retrieval research team, where like we build enterprise AI agents, and that's a context problem, right? So I have been thinking about agentic memory and building solutions. I'll mostly talk about the stuff that's out there, published today. And the core theme of this talk is that well-designed retrieval solutions for memory can take today's agents like really far, right? And we have seen this work and practice in industry and academia both. All right. So yeah, agentic memory is basically a retrieval problem, and it's a retrieval research era again because it's a new data type, right? So agents generate trajectories, and trajectories is a new data type. We know how to work with chunks, text, images, but we don't know how to work with agent trajectories, and also the insights that you can extract from them. And if you build a very good indexing and search mechanism, it gives you a very good memory system, right? So basically, a weak model with good memory beats a strong model without it, right? And there are like papers who show that GPT-4o mini can like get to 73%, where like and beat GPT-4 turbo, right? So these are like the academia is like behind, so these are like old models, but like the learnings still stay. Right, so basically, like all of these are solutions to a long context problem, right? There are like three approaches that are being explored currently in like various research teams. So first is like brute force scaling, where people believe that we can get from like 1 million context window to like 10 million just by brute force scaling. Like the hypothesis here is that the agent can just explore in context a bit more and then can do harder tasks. Right, so like the problem here now is to basically like come up with harder environments, harder tasks, and then also like solve the engineering challenges that go into like scaling the context. Right, and then they're like you can optimize the context so that like the solutions here are like building better harnesses or better models. We'll be talking about memory, which enable like just not until up to like 10 million, but today's solutions can scale to billions or trillions of context. the issue is that, like, of course, like it comes with a grain of salt, which is that controlling precision and recall is the hard part here, right? Like with million context window, you at least know that the language model has seen it. Whereas for these millions or billions of tokens, like in memory, they have to retrieve them. Right? So, yeah, with a good memory solution, it will equip the agent to achieve a lot more. Right? So basically, these are the two problems which only memory solves, and not the other two. First is the cost problem. The other two solutions so far are like very expensive, and also like they don't learn from experience. They are trying to just make the model good out of the box. Right? Memory basically gives us a mechanism to learn from experience. And right, so basically the trivial baseline that how we use agents today is that like you build an environment, which is your repo, and then you let an agent run inside it. Right? So now this environment is always like new unless you have some like agents.md or these files, which are like some primitive forms of memory. But these files help the agent adapt to this domain gap, right? So it hasn't explored this environment and it needs to, right? So basically, like agents have been trained on certain environments, which gives us this parameters space, and like they have been trained up to like certain level of tasks, right? Within in context exploration, you can expand the frontier, right? But the goal of memory is to design mechanisms so that this can go much further, right? Like on environment complexity side as well as task complexity side. Uh, right. So, like this is the primary difference between like if you have like 100 tasks that you have solved which are very similar, can you learn from those 100 tasks to solve the 101st task, right? So like this problem, I guess like memory is like uniquely positioned to solve it. Okay. Okay, so at a high level, what is memory, right? Like you are retrieving something into the context, right? Now, like it folds a lot of things, which is like what is it retrieving, what are we indexing, where's that index built, how's that index getting built, and how are you retrieving it, right? But like all of that aside, let's first focus on concepts first, right? Like what is it even retrieving? So there's like a spectrum. Like on the left side, it could be like rules and insights, which you can just put in there, right? Like, hey, do this, do that. Like, these can be either like in agents.md, people populate this themselves, whereas the Uber goal is to learn them, right? Like prompt optimization does this. Is Japa, stuff like that. Like these are methods that are basically like extracting rules and insights and then putting them into agents context, right? Like just prompt optimization. And on the right hand side, we have like these full trajectories where like you basically let the agent do tasks and like you look at the successful trajectories and then you just store them, right? Like these are long, but then like research has shown that like this is a better data type to store because these are like actual successful trajectories, right? So like here's the full spectrum, and then there are like hybrid methods which do both. Now like it's again like a compute versus like memory trade-off, where like in rules versus like on the insight side you need to do a lot of offline compute to extract these insights. Whereas in, like if you're just storing trajectories, like you can like just explore a lot of like positive similar trajectories at runtime and then extract insights from the most relevant ones. Right? So it's basically like more index heavy versus more search heavy style of memory solutions. Now, basically, today's solutions mostly look like humans navigating the agent to do all of these things, right? Like for example, if something goes well, you just ask the agent to like store that trajectory or store some build some insights and store them, right? So the current so there are solutions for all of these today, but they're mostly like human driven, right? So the world or like retrieval research is going into like making these solutions autonomous, right? So building the right index that can scale across all tasks. Okay, so basically you're already using memory, which is like using vibes. Like people have built solutions which are like very custom tailor-made. Like Cloud Code has markdown files which you navigate. Mem0 super memory is like chat solution which they evaluate on these like funny like trivial tasks. And then there are like solutions like Letta, which are like stateful agents where like they have first-party memory DBs. The agent has like actually understands these databases really well, and like they populate these like retrieval indexes by doing something called sleep time agents, which look at the agent's activity and then populate a lot of insights. Right, so it's like in my opinion, it's the best solution out there. But like mostly for like coding agents. And right, I guess the biggest problem in this space right now is that there are no hard evals, right? Like the evals that exist are like needle in a haystack, long mem eval, which don't really need you to understand the whole context, right? It's very needle in a haystack concept. Whereas like if you are working with an agent, really, right? Like you want it to understand the entire context of the conversation, like no matter how long it is. So like it's mostly an evals problem because like with good evals, like the solutions just come out. Okay, I'll talk about like this one paper, self-generated ICL, which was in Europe last year. I think I like this paper, and I guess like the part I like about it is that it just took retrieval to its limit. So like a standard React loop is basically you come up with a plan, and then there's a loop around like reasoning and then taking an action. Right. So what these guys did is that they introduced retrieval at every step, like the planning step, reasoning step, and the acting step, like the reflection step and the acting step. Right. So like that's the first thing. Like it's retrieval at all the right places rather than just the initial prompt building step. The second is like two-level curation, where like I'll talk about this a bit more, where the way they assemble the right trajectories in the right memory is slightly innovative and well thought out. Okay, so retrieval baked into the so this is the first point where like the standard React loop looks like this. Like there's the goal, the agent plans, and then acts and observes and reasons. Right, so this is the standard loop, which all the agents today do. Right, like they're all React agents. With memory, like they curate this memory DB, which interacts at all of these three steps, and they show that if you can design these well, they actually outperform all the solutions that exist there, right? Like out there. So it's a very simple concept, but applied well can really scale. Right. So the second idea they had was like not all memories are worth keeping. So like they do two things. One is that they keep like several sets of memory, and then they do some kind of genetic evolution and pruning. That's the first. The second is like they hypothesize that for a given task, if you roll it out like 200 times, and like one rollout is better than like the others, like they'll just replace it across all the DBs rather than having the DB local versions. So yeah, I won't be able to cover like the entire details. I'll say that you just take a read of the paper. It's very well written. But yeah, the final results were that like a standard React loop was 73% with few-shot prompting, whereas like with the memory, it was able to get 93%. Cool. So like I covered on this point earlier, which was that like there are like two sides of the spectrum, right? The left end is where you're storing insights, and the right end is where you're storing trajectories. Right, so if you're only storing trajectories, then you have to retrieve the right trajectories and do some processing like during like when the agent runs. Right, so this is the live compute paradigm. So this is like expensive burn context tokens, but it is better in a sense that it can extract the right insights. Sleep time compute needs more like inductive biases where you need to know what kind of insights you need to extract. And yeah, so basically, if you extract the bad insights, like they can even hurt, right? So there are like papers which claim that, which are actually like showing that live compute is better, but it's just more expensive. Okay, I'll just skip this slide. It's just that like the field took some time to get to like a pure retrieval solution. There were like sparks of like fake retrieval solutions to optimize memory and like reflection. And then it got to expel, and then self-gen ICL was like a much more pure retrieval solution. Right, so, okay, so all of that said, I believe like the memory work in research so far, like in in academia research so far has not given enough justice to coding agents, and that's primarily because like no benchmarks exist. Like until like the SWE context bench came out, which is like a post processing on top of SWE bench, which allows you to evaluate memory solutions, right? So now like researchers have the right tools to build it, and also like you can basically evaluate your memory solutions on this benchmark, and also like so basically the tooling is coming up now, and I believe like we'll have much better coding memory solutions soon. Right, so takeaways from this slide, from the talk today, memory is retrieval over agent's experience, and if done well, can really improve agent's performance. There are like different paradigms and like approaches which people are taking to solve this. One is like insight heavy, the other is like positive experience, just store the positive experiences and do the insight inference at like query time. And like the coding agents are the frontier, like the benchmarks recently came out. I guess like we'll also see academic papers around memory soon. Yeah, so the North remembers, but can your agent? So I guess like if you design retrieval solutions, they could. Cool. Yeah, that's all.
Yeah, personally, I'm really a fan of like contextual because like I followed every like the paper since the rack has been had some tractions on the internet. Do you have any like questions about it?
Yeah. So these results for with the GPT-4, I was wondering if you have any, if you're seeing any like improvements over like current models.
Yeah.
6.
So like no, okay, so I'll give you an example over like a recent model like 4.6 Haiku versus 4.5 Sonnet Opus. So not on this benchmark, but on internal benchmark, you can get like Haiku to Opus performance with them on like some benchmarks. So yeah, but basically, I feel like right now they're not good enough to get the core performance boost, but like Haiku will be like much more efficient and like get the same accuracy.
And then for retrieving from raw trajectories, are you looking specific for like links or just like what are you looking to retrieve out of raw trajectories?
Oh, right. So let's say you have like 100 tasks that the agent went through, right? Now, like those tasks, they were successful, right? Like by some metric. Now, if they were successful, clearly they were like successful patterns about what agent did right, right? Now, like agents are really good at like this in context learning and like, with few short examples, right? So it's basically just simulating that. Like rather than like condensing all of that into a prompt, you just show that as an example, right? So for example, there are patterns like if there is an API, like first read the documentation and then like call the API, right? Like this is a pattern. And for some APIs, it's like it's a good pattern, right? Now, like if an agent does that once, right, you want it to repeat that pattern if it was successful, right? Whereas like just capturing this pattern from one trajectory is hard, right? Rather than just mimicking it the second time. So that's why I think the right side is like expensive but generally better because you're just showing the good examples.
Yeah, cool. Thank you very much. So last but not least, we have two things. The first thing is that we are going to like give away from our sponsors the credits. So this is one company. It's like Psionic that I'm working for, and then they're like trying to give away for like $100. It's open browser stuff basically. So basically, you have some similar experience to the open browser, and they give $100 API project per review. So like if you take this QR code here, you can get a free LLM credits itself. Yeah. So just try to like scan the code. I just like try to take a bit.
Which model supports?
Huh?
Which model supports in the open gateway?
Which model? What?
What model supports in the
What model?
Model.
Basically, we have all the models in Vortex AI Studios and then generative AI Studios. Basically, it has some effectively in the Anthropic and OpenAI and some from the Oliver clouds.
Wonderful.
Yeah, cool. Thank you.
Latest version.
Yeah, latest ones. Yeah.
So you can pick anyone.
Yeah. So trend pick and provider as well. Yeah. And last one is we just want to like call all of the audiences, even on the backstage and to take offers, or just like or anything stuff. Yeah. So can you just like summon all of the back first? Thank you. Yeah. Woohoo! So like this end of the OmOCon San Francisco, it's a bunch of the speakers here. It's always my style to wanna bring all the kind of academic speakers to be here and just to break a whole bunch of hours. Yeah, with just academic speakers as well. That's my thing. Okay, have you finished like taking your captures of it with QR code? Oh, nice one. Yes. Yeah, just next one is to take a photo. Yeah.
Next month.
Well, I think we're gonna be next month as well, and the next one is in Singapore. So can you just like you guys all like comes up? Yeah.
Come here.
Come here, and then soon you can help us to take a photo with it. Thank you. Yeah. Yeah, that's he designed it. That's really nice one. It's on the t-shirt here too. Yeah.
T-shirt is designed by Q.
Yeah. Oh, this is Q's design. Okay. It's not a nano banana stuff. I love it. You guys can just come up. Yeah, all things. On the full story. Yeah. Come. And I'll play. Yeah. And you need to can you just come up any kinds of like kind of I don't know some slogans or some signals.
We have the slogan.
What the heck is this? It's good.
We should use this one.
West side.
You are W.
Okay. Can you just explain to the As an abbreviation of ultra. Ultra work.
So Singer said ultra, we said word. So ultra word.
Okay. Are you prepared? Yeah. Okay. Gotcha. So let's just try the one on tap. Okay. So ultra word.
Can you take a video?
Video. Oh, nice option.
This is really damn good. Good event.
I'm trusting you.
Oh yeah.
Not gonna lie.
This is video?
Yeah. Okay.
Ultra
word.
Yeah.
Thank you very much. Yeah, thank you very much. Yeah, thank you much for coming here. And then don't forget to scan QR code for your 100 box API credits. And we're going to meet in the next time, okay?
The credit here is for open router.
Open gateway, which is open route, alternative open route.
Alternative.
What is the difference between open router and open gateway?
Like it's basically we have like more kind of the Vertex AI Studio providers, like so more the billings, more kind of support us.
Okay, it's new or?
It's my company's work.
Yeah, but when did you start open?
It's 3 months ago.
Okay, that's right.
Yeah. I'm making for it.
Thank you.
Yeah.
I need to study English more.
Yeah, thanks for coming here.
Thank you for coming. Oh yeah, how many days? The whole week. Or this week? Wednesday. Let's go to the airport. Let's talk about your study. Just call me. Figure it out. Yeah.
Yeah, so sure. Yeah, so sure. Okay, anyone's gonna help us? Oh, yeah. We're trying to figure out. Okay, we've got some views on oh, they could just say out there in the street. So, hell yeah, just the same email. No, just one special mention. I just want to get there and see what the open source. Yeah, they are leader in yeah, I can imagine. Yeah.
Oh yeah, I like it, but I'm not sleeping last night. So I feel a bit sleepy. So I can follow the old context. The presentation is good.
You don't have context about what the exact thing would work. It's not, I don't know. You are very high level. Yeah. By the way, what exactly is it's like enterprise apps, like we used to do like drag agents. I think you want to basically very general knowledge. So drag is a very small part of it. Whole lifetime of that's okay. I think production like in research production is more like optimization. You now set the agent to learn from it. All users interaction you have to learn it. You can actually use
I was just wondering, like, your thoughts are on recursive language models, where there's a repo. I think the concept you're trying to do is to separate the context from the actual where like everything that injected into the context of the agent executes. So it's like a sub agent that's just dedicated to it.
If you think about it, just tools are also like a pointer to external This is just basically a pointer without
Correct. You're just letting the language model figure out the parameters. It's true. They come from the counting. The
so the paper itself is like more general as in like we use to train models in that paradise.
I don't think it's just like thinking it more general and everything to get there. I think they are bringing something where symbolically the language model doesn't have to think in certain dimensions and then just try to sit. Because I can imagine it just
I want to do that. But that you're gonna
Make a loop, like create video.